The image is a ghost, a faint, spectral smudge on a photographic plate, locked away in a dark drawer. It shouldn't be there. The plate was wrapped in thick black paper, sealed from any light. It was placed in a drawer with a small sample of uranium salts, a mineral that glowed faintly under sunlight. But in the total, silent darkness of that drawer, something else was happening. An energy, unseen and unknown, was bleeding out from the rock. It passed through the paper, through the dark, and burned its own ghostly signature onto the emulsion. This was not a discovery made in a flash of light. It was found in the quiet dark, a whisper from a world hidden within our own. A world of unimaginable power, waiting patiently to be seen. The scientists who first glimpsed this ghost had no idea what they were looking at. They thought they had found a curiosity, a scientific parlor trick. They had no way of knowing they had just found the key to a fire that could outshine the sun. This is Welcome to the Dark Historian. Get comfortable, dim the lights, slow your breathing, let the world outside fade away, the sounds of your room, the weight of your day, let it all drift. We are going somewhere else now, not to a battlefield, not yet. We are going to a place much smaller, to a space so infinitesimally small, it is mostly nothing at all. We are going inside the atom, and we are going to watch as the brightest minds of a generation pry it open, and in doing so, change the world and the very meaning of fear forever. Our story begins in a time that felt certain of itself, the late 19th century, a world of steam and steel, of gaslight and reason. Physicists felt they were nearing the end of their work. They believed they had a neat, tidy map of the universe. Gravity, electromagnetism, thermodynamics. The great laws were known. The world was a predictable machine, a great clockwork wound up by a distant god, and its gears were atoms. What was an atom? For 2,000 years, it was just an idea, born in ancient Greece. The idea of atomos, the uncuttable, the smallest possible piece of anything. The final, solid, indivisible Lego brick of reality. By the 1890s, scientists had proven they were real, but they were still thought of as tiny, hard, billiard balls, simple, solid, eternal. There was nothing more to see, or so they thought. The first crack in this perfect, solid wall of reality appeared in a laboratory in Paris. In 1896, a physicist named Henry Becquerel was fascinated by a recent discovery: X-rays. These mysterious rays could pass through solid objects. Becquerel wondered if minerals that phosphoresced, that glowed after being exposed to sunlight, might also emit these strange new rays. So he began his experiments. He would take a sample of uranium salt, place it on a wrapped photographic plate, and leave it in the sun. As he expected, the sunlight made the salt glow, and when he developed the plate, he found an image. The rays from the glowing salt had penetrated the paper. It seemed simple. Sunlight in, X-rays out, but then the Parisian weather turned. For several days, the sky was overcast. There was no sun. Frustrated, Becquerel put his experiment away. He took his latest piece of uranium salt, still resting on its carefully wrapped photographic plate, and slid it into a desk drawer to wait for a sunny day. This is where history pivots. Not on a decision, but on a whim. On a cloudy day. After a week, Becquerel, perhaps out of boredom or a nagging sense of scientific duty, decided to develop the plate anyway. He expected nothing. Maybe the faintest of images, a residual ghost. But what he saw must have stopped his heart. The image burned onto the plate was sharp, clear, and intense. It was even stronger than the images from the sun-drenched experiments. The sunlight had nothing to do with it. The rock was emitting this energy all by itself. In the cold, silent dark of the drawer, it was constantly radiating an invisible force. It wasn't reflecting energy, it was creating it. Think about what that means. It violates one of the most fundamental laws of the universe as they understood it, the conservation of energy. Energy cannot be created or destroyed. A fire consumes wood to make heat. A steam engine burns coal to make motion. You always have to put something in to get something out. But this rock, this dead piece of mineralite, was a furnace that never went out. It was a spring that never ran dry. Where was this impossible energy coming from? Becquerel had no answer. He had stumbled upon a fundamental secret of the universe. He had discovered radioactivity, but he didn't know what it was. He had simply opened a door, and now someone else was about to walk through it. Her name was Maria Skłodowska, a brilliant, fiercely determined Polish student living in Paris. We know her as Marie Curie. At the time, she was looking for a topic for her doctoral thesis. Something new, something no one else was exploring. She heard of Becquerel's strange uranium rays and was immediately captivated by the mystery. It was a field so new it didn't even have a name. It was a perfect challenge. She was joined by her husband, Pierre Curie, himself an accomplished physicist. Together, they began their work not in a grand university laboratory, but in what was described as a miserable old shed. It was a drafty, leaking storeroom, freezing in the winter and suffocating in the summer. This is where the atomic age was truly born. Not in a gleaming facility, but in a cold shack, driven by pure, obsessive curiosity. Marie started by testing every element she could find for these mysterious rays. She used a sensitive electrometer, an instrument designed by Pierre, to measure the faint electrical charges the rays produced in the air. She confirmed that uranium emitted the rays. She discovered that thorium did as well, but then she found something that made no sense. She was testing a sample of pitchblende, the raw ore from which uranium is extracted. Logically, it should have been less radioactive than pure, refined uranium, but it wasn't. It was 4 or 5 times more powerful. The conclusion was inescapable. There had to be something else in the pitchblende, a new element, unknown to science, present in tiny quantities, but radiating energy with an intensity that dwarfed uranium. And so began an epic labor. Marie and Pierre Curie set out to isolate this unknown element. They obtained tons of pitchblende waste from a mining company, and for the next 4 years, in that miserable shed, they performed back-breaking work. This wasn't the clean, precise science you might imagine. This was industrial labor. Marie, in a stained and acid-burned smock, stood for hours by a boiling cauldron, stirring bubbling vats of black, tar-like ore with an iron rod as thick as her arm. They were trying to boil down a mountain to find a single grain of sand. Can you picture it? The fumes that made them cough, the constant physical exhaustion. Marie's hands were raw, cracked, and burned by the chemicals and the strange new substances they were handling. At night, they would return to their work, and they would see it. The vats and beakers in their dark laboratory were glowing, faintly, beautifully, with a ghostly blue-green light. It was the energy they were hunting, making itself visible. We had a wonderful time in that miserable old shed, she would later write. First, they isolated one new element. They named it polonium, after Marie's beloved, occupied homeland of Poland. But even with polonium removed, the pitchblende was still intensely radioactive. There was something else, something even more powerful. Finally, after 4 years of relentless effort, after processing several tons of ore, they succeeded. They had isolated 1/10 of a gram of a new substance, a salt of a new element. It glowed in the dark with a steady, ethereal light. It was constantly warm, producing its own heat, day and night, without any fuel. It was millions of times more radioactive than uranium. They named it radium, from the Latin word radius, meaning ray. The world was enchanted. Radium seemed like a magical substance, a miracle of science. It was put into everything. Face creams that promised a youthful glow, toothpaste, tonics you could drink for vitality, chocolate. There were radium spas where the wealthy could bathe in radioactive water. People wore pendants of radium so they could watch them glow in the dark, holding this little piece of cosmic fire against their skin. No one understood the danger. They saw the light, but not the damage it was doing. The same energy that could burn an image on a photographic plate could also burn the cells of a human body. The Curies themselves suffered from it. Their fingers were burned and scarred. They were constantly tired, sick. Pierre was eventually killed in a street accident, but Marie would die decades later from aplastic anemia, her bone marrow destroyed by a lifetime of exposure to the very element she discovered. The notebooks she kept in that lab are still so radioactive today that they have to be stored in lead-lined boxes. To read them, you have to wear protective clothing. Her own discovery was silently killing her, but the central question remained: what was this radioactivity? Where did this inexhaustible energy come from? The discovery of radium didn't answer the question. It just made it louder. The answer would come from another corner of the scientific world, from a booming, boisterous physicist from New Zealand named Ernest Rutherford. Before we follow him and witness the moment he shattered our understanding of reality, I want to take a brief pause. If you are finding this journey into the hidden corners of history a source of calm, a way to quiet your mind, please consider subscribing to The Dark Historian. It's a simple, free way to support the channel and ensure these stories continue. Your presence here is deeply appreciated. Now let us return to the mystery, back to a world on the verge of a revelation. Rutherford was a brilliant experimentalist. He was fascinated by the rays coming from these new radioactive elements. He discovered they weren't all the same. He found two distinct types. One he called alpha rays, which were heavy and could be stopped by a sheet of paper. The other he called beta rays, which were lighter and could pass through thin metal. At the time, the accepted model of the atom was J.J., Thomson's plum pudding model. Imagine a blueberry muffin. The muffin itself is a cloud of positive charge, and the blueberries, the electrons, are scattered throughout it. The atom was seen as a soft, solid, mostly uniform ball. Rutherford decided to use his alpha particles as tiny probes to explore the inside of the atom. It would be like firing microscopic bullets at the plum pudding to see what happened. The experiment he designed, carried out by his assistants, Hans Geiger and Ernest Marston, in 1909, was elegant in its simplicity. Picture a room, dark like Becquerel's drawer. In the center, there is a source of alpha particles, radium, firing a steady stream of them. In their path is a piece of gold foil, unimaginably thin, hammered down to be only a few hundred atoms thick. Surrounding the foil is a circular screen, coated with a material that flashes with a tiny spark of light, a scintillation, every time it's hit by an alpha particle. What did they expect to see? Based on the plum pudding model, the alpha particles, which are heavy and fast-moving, should have punched right through the soft pudding of the gold atoms. They might be deflected just a tiny bit, like a cannonball going through a mist. But essentially, all the flashes of light should appear on the screen directly behind the foil. And for the most part, that is exactly what happened. Click, 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 thousands of tiny flashes, all clustered in a small area. The work was tedious. The researchers had to sit in total darkness for hours for their eyes to adjust, just to see the faint sparks. But then, they saw something impossible. Every once in a while, maybe 1 in 8,000 times, a flash would appear on the screen way off to the side. A particle had been deflected at a huge angle. And even more shocking, a few flashes appeared on the screen on the same side as the alpha source. A particle had bounced back. Rutherford was stunned. He later said, "It was quite the most incredible event that has ever happened to me in my life. It was almost as incredible as if you fired a 15-inch shell at a piece of tissue paper and it came back and hit you." The plum pudding model was dead. It could not explain this. A soft muffin cannot bounce a cannonball backwards. There was only one possible conclusion. The atom was not a soft, solid sphere. Instead, almost all of its mass and all of its positive charge must be concentrated in an incredibly small, incredibly dense point at its center. A nucleus. This was a revolution in thought. The atom, the building block of our solid world, was in fact almost entirely empty space. Let that sink in. If you could scale an atom up to the size of a vast cathedral, the nucleus would be the size of a single fly buzzing in the center. The electrons would be like motes of dust, miles away, orbiting in that vast, empty space. The chair you are sitting on, the bed you are lying in, your own body, it is all a phantom. 99.99% empty space. The feeling of solidity you experience is just the electrical repulsion between the electron clouds of your atoms and the atoms of the object you're touching. You have never truly touched anything in your life. This discovery of the nucleus was the key that unlocked the first mystery, the mystery of radioactivity. Rutherford realized that the enormous energy released by radium was coming from this nucleus. Some atoms, like uranium and radium, have large, unstable nuclei. They are too full, too energetic. To achieve stability, they spontaneously break apart. They decay. And when they do, they fire out pieces of themselves. Those pieces are the alpha and beta particles Rutherford had studied. And when a nucleus decays, it transforms into a different element. Radium decays into radon gas. Uranium eventually decays, through a long chain, into stable lead. This was alchemy. The medieval dream of turning one element into another was real. It was happening spontaneously all around us. And most importantly, the process released a staggering amount of energy. A tiny, tiny amount of mass inside the nucleus was being converted directly into pure energy. This was the source of the Curie's glowing light, of Becquerel's ghost on the photographic plate. It was nuclear energy, the fire hidden at the heart of matter. By the early 1910s, the picture was becoming clear. The world was not what it seemed. Reality was a delicate dance of tiny particles in a vast void, all governed by forces of unimaginable power, locked away inside a nucleus so small it was barely there at all. The scientists of this era had done something extraordinary. They had peered into the heart of creation. They had found a power source that dwarfed anything humanity had ever known. They stood at the doorway Becquerel had opened, looking into a new world, lit by the eerie glow of radium. There was a sense of awe, of wonder, but there was not yet a sense of dread. They understood that this energy was being released spontaneously, slowly, atom by atom, over thousands of years. They could observe it, measure it, even use the gentle heat of radium for good. But they had no idea how to control it. They couldn't speed it up. They couldn't slow it down. And they certainly couldn't imagine a way to make all the nuclei in a piece of uranium decay at once. The idea of unleashing that power in a single, violent instant was pure science fiction. The key to the lock had been found, but no one had yet figured out how to turn it. The story was just getting started. The quiet, academic pursuit of knowledge, carried out in dusty labs and dark rooms, was about to be swept up by the tides of history. War was coming to Europe, and with war comes a desperate hunger for new weapons. The quiet whisper from the nucleus was about to become a roar, and it only gets louder from here. For now, just rest in this moment of discovery, a time before the bomb, a time of pure potential. Think of that vast, empty cathedral of the atom, the single fly buzzing at its center, an entire universe of power coiled like a serpent in a space too small to see, waiting, just waiting for the right mind, or the wrong one, to come along and set it free. The world was about to change, and it would never be the same again. That change did not arrive like a thunderclap. It was not a single, sudden moment. It was a creeping dread, a shadow stretching across a map of Europe, growing longer and darker with each passing month of the late 1930s. In the halls of power, men in fine suits spoke of peace, of agreements and understandings. They signed papers in Munich and declared they had secured peace for our time. But on the streets, in the cafes, in the quiet of university laboratories, you could feel something else. A tremor, a deep, unsettling vibration that hinted at a coming earthquake. You have to understand the air people were breathing then. It was thick with ideology, with nationalism, with the rhythmic stomp of marching boots broadcast over the radio. In Germany, a new kind of power was consolidating. It was brutal, efficient, and it had a voracious appetite. It had swallowed Austria. It had dismembered Czechoslovakia. And all the while, it spoke of destiny, of a master race, of a 1,000-year empire. It was a power that celebrated strength and despised weakness. And here's the thing about that kind of power, it is always looking for a bigger stick, a better weapon, the ultimate advantage. At the very same time, in the hushed, rarefied world of theoretical physics, another kind of power was being uncovered. Not political power, but something far more fundamental. The power locked inside the atom. For decades, scientists had treated the atom like a delicate watch, taking it apart piece by piece to see how it ticked. They were explorers charting an invisible continent, and they had just stumbled upon its volcanic heart. In late 1938, in a laboratory in Berlin, the chemists Otto Hahn and Fritz Strassmann performed an experiment they could not understand. They had bombarded uranium with neutrons, and the results made no sense. They wrote to their former colleague, Lise Meitner, a brilliant physicist who had been forced to flee Germany just months earlier simply because she was Jewish. Picture her, an exile in the cold of a Swedish winter, reading the letter from her old friends. She discusses it with her nephew, Otto Frisch, and as they walk together in the snow, the truth dowishes on them, a staggering, world-altering truth. Hahn and Strassmann hadn't just chipped a piece off the uranium atom. They had split it in two. They had achieved nuclear fission. And in that violent rupture, a tremendous amount of energy was released, along with a few extra neutrons. Neutrons. That was the key. This is where the story shifts from a scientific curiosity to a global nightmare. And to understand that shift, you have to meet a man named Leo Szilard. Szilard was a Hungarian physicist, a genius. But more than that, he was a man who saw the future. He was restless, anxious, a bundle of nervous energy who seemed to live 5 minutes ahead of everyone else. And he was terrified. He had fled Germany the moment the Nazis came to power, sensing what was coming. He had moved to London, and it was there, on a dreary day in 1933, standing at a crosswalk waiting for the light to change, that the entire atomic age unfolded in his mind. He wasn't thinking about bombs. Not yet. He was thinking about energy. He was thinking about those extra neutrons that Meitner and Frisch would realize were released during fission. Szilard imagined one atom splitting, releasing energy, and 2 or 3 new neutrons. What if those neutrons went on to hit 2 or 3 other atoms? And they split, each releasing more neutrons, which then hit even more atoms. It was a cascade, a chain reaction, a fire that would not consume wood or coal, but matter itself. An atomic fire. The idea haunted him. He even took out a secret patent on the concept, not to make money, but in a desperate attempt to control it, to keep it out of the wrong hands. When he heard the news of Hahn and Strassmann's discovery, his blood ran cold. The abstract idea he had envisioned on a London street was now possible. It was real, and the discovery had been made in the heart of Nazi Germany. Now you feel the chill, don't you? The world's most brilliant physicists, the pioneers of this new science, were in Germany. Men like Werner Heisenberg and the raw material, uranium, was readily available. The world's richest deposits were in the Joachimsthal mines in Czechoslovakia, the same Czechoslovakia that Germany had just conquered. All the pieces were there, a regime that glorified war, the scientists to understand the physics, and the material to build the weapon. It was a perfect, terrible storm. Szilard knew, in his bones, that German scientists would see the same thing he saw. They would understand the military applications of a runaway chain reaction. They would know that a bomb of unimaginable power was now, for the first time in human history, theoretically possible, a single bomb that could level a city, a single bomb to win a war. He felt like a man shouting a fire warning in a crowded theater where the audience was deaf. He raced to America, where many of his fellow refugee scientists had also fled. He found them at Columbia University at Princeton. He found Enrico Fermi, another giant of physics who had fled fascist Italy. Together, they confirmed the German experiments. They split the uranium atom in a lab in the basement of a university building in New York City. They proved that extra neutrons were indeed released. The chain reaction was not just a theory, it was a certainty. Schilard's frantic energy intensified. He believed they were in a direct, undeclared race with Nazi Germany, a race that humanity could not afford to lose. His first instinct was to try and impose secrecy. This was completely alien to the culture of science. Science thrives on openness, on publishing results, on sharing discoveries so others can build upon them. But Szilard saw that this discovery was different. This knowledge was too dangerous to share. He begged his colleagues across the world, especially the French physicists who were also doing key research, to stop publishing their findings, to voluntarily pull a cloak of silence over the entire field of nuclear physics. Imagine the struggle. These are men and women whose entire lives are dedicated to the pursuit of knowledge, and now one of them is telling them to hide it, to bury the most profound discovery of their generation. Some agreed. Many did not. The French, in particular, were proud of their work and refused. The information continued to be published. The secret was out, and every new paper, every new data point, was another potential clue for the scientists working in Berlin. Szilard was convinced that time was running out. The American government was doing nothing. They were oblivious. The military leaders were still thinking in terms of battleships and bomber planes. How could you explain a weapon that operated on the principles of quantum mechanics? How could you make them understand a threat that was, as yet, entirely invisible? He needed a voice. Not his voice, the voice of a high-strung, relatively unknown Hungarian refugee. He needed a voice that could not be ignored. A voice that was synonymous with genius itself. He needed Albert Einstein. Einstein was, by 1939, living a quiet life in Princeton, New Jersey. He was a global icon, the most famous scientist on Earth. His face was known everywhere. His ideas had reshaped our understanding of the universe. He was also a committed pacifist. He had seen the horrors of the First World War and had spoken out against militarism his entire life. He was the last person you would think to approach about building a super weapon. But Szilard knew two things. Einstein understood the physics. And more importantly, Einstein understood the Nazis. He was a German Jew who had been stripped of his citizenship, whose books had been burned in public bonfires. He knew the nature of the evil that was rising in his homeland. So, on a long, hot summer day in July of 1939, Leo Szilard and another Hungarian physicist, Eugene Wigner, drove out to the small cottage on Long Island where Einstein was spending his vacation. Picture the scene: the quiet, peaceful shoreline, the gentle lapping of the waves, and these two intense, worried men walking up to the door of a simple house to discuss the end of the world. They found Einstein in slippers, relaxed and welcoming. They sat at a simple wooden table, and Szilard began to explain. He spoke of fission. He spoke of the extra neutrons. He spoke, slowly and carefully, of the possibility of a chain reaction. Einstein followed the science, of course, but he hadn't made the leap. He hadn't connected the dots from a laboratory curiosity to a weapon of war. As Szilard laid it all out, the dawning horror was visible on Einstein's face. He was a man who had unlocked the deepest secrets of the cosmos. The famous equation, E equals mc squared, his equation, was the very formula that explained the immense energy release from fission. But he had always considered it a matter of theoretical cosmic importance. He never believed humans would be able to tap that power on any practical scale. Szilard explained that it was now practical. He told Einstein about the German research, the conquest of Czechoslovakia, and its uranium mines. He painted a picture of a world where Adolf Hitler possessed a weapon that could hold every other nation hostage. As the weight of it all settled in, Einstein uttered a quiet, fateful sentence. "I never thought of that." In that moment, the pacifist was confronted with a terrible paradox. The only thing worse than building such a monstrous weapon would be for the Nazis to build it first. The only way to prevent its use by a tyrant might be to possess it yourself. It was a devil's bargain. To protect peace, you might have to create the greatest weapon of war ever known. Einstein was convinced. He knew he had to do something. But what? Who could they even talk to? They were just scientists. They thought of writing to the Belgian government to warn them about their large uranium stocks in the Congo. They thought of writing to a friend in the French cabinet. But these were half measures. They needed to go to the very top. They needed to get the attention of the President of the United States, Franklin Delano Roosevelt. They knew they couldn't just write a letter and drop it in the mail. It would never reach him. It would be buried in a pile of papers by some low-level secretary. They needed an intermediary, someone with access to the White House, someone the president trusted. Through a series of connections, they found their man, Alexander Sachs, a respected economist and an occasional informal advisor to Roosevelt. Sachs understood the gravity of the situation, and more importantly, he knew how to talk to the president. He promised to deliver the letter personally. So, they began to draft it. This was not a simple task. How do you write the most important letter in human history? Szilard wrote a first draft in German. Einstein translated and softened it. They went back and forth, weighing every single word. The language had to be precise, sober, and utterly convincing. It couldn't sound like science fiction. It couldn't sound like the ravings of panicked refugees. It had to sound like an urgent, credible, and existential warning. Let's pause and consider the words they chose. "Sir," it began, "some recent work by E. Fermi and L. Szilard, which has been communicated to me in manuscript, leads me to expect that the element uranium may be turned into a new and important source of energy in the immediate future." Notice the calm, academic tone. No panic, just facts. Then it continues. It appears almost certain that this could be achieved in the immediate future. This new phenomenon would also lead to the construction of bombs, and it is conceivable, though much less certain, that extremely powerful bombs of a new type may thus be constructed. extremely powerful bombs of a new type. Think about that phrase. The understatement is chilling. They are not talking about a bigger cannon or a more destructive blockbuster. They are talking about a fire stolen from the sun. A power that could crack the very foundation of a city and leave nothing but a shadow on the stone. The letter goes on to urge the government to take action, to speed up experimental work, to secure a supply of uranium ore for the United States. And then comes the most crucial part, the part designed to jolt a world leader out of his complacency. I understand that Germany has actually stopped the sale of uranium from the Czechoslovakian mines, which she has taken over. That she should have taken such early action might perhaps be understood on the ground that the son of the German Undersecretary of State, von Weizsäcker, is attached to the Kaiser Wilhelm Institute in Berlin, where some of the American work on uranium is now being repeated. This was the masterstroke. It wasn't just a theoretical threat anymore. This was intelligence. It was a clear signal that the enemy was already moving. It connected the abstract science to the concrete actions of the Nazi regime. It was the sentence that turned a scientific possibility into a clear and present danger. Einstein read the final draft. He must have paused, the paper in his hand feeling impossibly heavy. He was a man who loved humanity, who believed in peace and reason, and he was about to sign his name to a letter that he knew could initiate a terrifying arms race, a race to build a weapon of mass death. But the alternative, a world where Hitler's Germany had that weapon and the Allies did not, was simply unthinkable. He picked up his pen, and with a simple signature, Albert Einstein, the gentle pacifist, set in motion the largest and most terrifying weapons project in history. The letter was dated August 2nd, 1939. But the story of the letter wasn't over. It still had to make its journey. Sachs, the chosen messenger, was ready, but the world was moving too fast. On September 1st, 1939, just weeks after the letter was signed, Germany invaded Poland. The Second World War had begun. The shadow that had been creeping across Europe had finally become a consuming darkness. In the chaos and urgency of a world now at war, Sachs found it difficult to get a meeting with the president. Roosevelt was overwhelmed. The world was on fire. Weeks turned into months. The letter, the most urgent warning imaginable, sat waiting. Schillard grew frantic, imagining German scientists working day and night, getting further and further ahead. He worried the chance had been lost, that their warning would arrive too late. Finally, on October 11th, Alexander Sachs was shown into the Oval Office. He was carrying the letter. He had the president's ear. The fate of the world now rested not on physicists or equations, but on the conversation between two men. One, a president grappling with the outbreak of a global war. The other, an economist carrying a message from a group of refugee scientists about a bomb that could harness the power of the stars. Everything hung in the balance. The letter was open on the desk. The warning had been delivered, and a terrible question now filled the silence of the room. What would the president do? The answer was not a word. It was an avalanche, a decision made not in a single moment of clarity, but in the slow, grinding realization that a new kind of war had already begun. A war fought not on battlefields, but in laboratories. A war of equations and theories, where the prize was not territory, but the very power of the stars themselves. Franklin Delano Roosevelt, a man who understood power, now faced a power beyond any precedent. And so, the wheels began to turn. Slowly at first, then with gathering, unstoppable force. The initial effort was small, scattered. A committee was formed. Budgets were allocated, a few $1,000s here, a few thousand there. It was called the S1 Committee, a name so bland, so utterly forgettable. It was the perfect camouflage. Scientists at universities across the country began their work in quiet, isolated pockets. They were exploring the very edges of known physics, wrestling with concepts that seemed more like science fiction than practical engineering. Could a chain reaction be sustained? Could it be controlled? And most terrifying of all, could it be weaponized? The early results were promising, but theoretical. They were whispers of a possibility, not the roar of a certainty. But whispers in wartime travel fast, and as the world plunged deeper into conflict, as reports from Europe grew more and more dire, the whispers grew louder. The project needed more than just brilliant minds. It needed a hammer. It needed a force of nature to take this fragile, theoretical idea and forge it into a physical reality. It needed a man who did not deal in whispers, but in concrete and steel. And so, in September of 1942, the project was handed to the United States Army Corps of Engineers, and to one man in particular. A man who had just finished building the largest office building in the world, the Pentagon, a 5-sided fortress of bureaucracy and military might, raised from a swamp in a breathtakingly short amount of time. His name was Leslie Groves. Imagine a man built like a bulldog, gruff, demanding, with an ego as vast and solid as the structures he erected. Groves was not a scientist. He had little patience for the abstract musings of theoretical physicists. He was a builder. He saw the world in terms of logistics, deadlines, and results. He was, in his own words, a son of a bitch, and he was proud of it. When he was given command of this new, top-secret weapons project, he was deeply disappointed. He had wanted a combat command overseas, a chance for glory on the battlefield. Instead, he was being handed a bizarre, long-shot science experiment. But Leslie Groves had a defining characteristic. Once he was given a job, it became his entire world. He would move heaven and earth to see it completed. On time, under budget if possible, but completion was the only thing that truly mattered. He read the initial reports, the scientific briefs, and though he may not have understood every equation, he understood the conclusion. He understood the potential. And in that potential, he saw the ultimate construction project, the ultimate challenge. His first actions were swift and decisive. He didn't ask for authority, he assumed it. He didn't request resources, he demanded them. The project, he realized, was starved. It was a brilliant idea dying on the vine for lack of industrial muscle. So he gave it muscle. He secured a priority rating for materials higher than any other wartime project. It was called AAA. If the bomb needed steel, it got steel, even if that meant a factory building tanks had to wait. If it needed copper, it got copper, even if that meant the nation's supply of pennies had to be suspended. In fact, they needed so much copper for the massive electromagnets to separate uranium isotopes that they turned to the U.S. Treasury. They borrowed and used almost 14,000 tons of silver. Silver from Fort Knox, drawn into massive wires and wound into colossal machines, a precious metal used for a purpose its owners could never have imagined. Groves was a whirlwind of motion and command. He acquired vast tracts of land. He authorized the construction of factories the size of cities. He set in motion an industrial enterprise that would, at its peak, employ over 130,000 people and consume a significant fraction of the entire nation's electrical power. And almost none of those people would have any idea what they were actually building. The name of the project was officially changed, the Manhattan Engineer District. It was a name chosen for its sheer, boring anonymity. It sounded like a group that dredged rivers or built dams. It was headquartered in New York City, but its soul, its true centers of gravity, would be located in places that did not exist. Places that would have to be built from nothing hidden away from the prying eyes of the world. But Groves knew he couldn't do it alone. He could build the factories. He could manage the logistics. He could move the mountains of material and manpower. But he couldn't build the bomb itself. He needed a scientific director. He needed a mind that could orchestrate the symphony of physics, chemistry, and engineering required to turn a theory into a device. He needed someone who could speak the strange, esoteric language of the scientists, but also translate it into a language of progress that a general could understand. The choice was not an obvious one. Many of the leading physicists of the day were Nobel laureates, established giants in their fields, but Groves saw something in a different man. A man who was brilliant, yes, but also complicated. A man of contradictions. Slender, intense, with piercing blue eyes that seemed to look right through you. A theoretical physicist from the University of California, Berkeley. His name was J. Robert Oppenheimer. If Groves was the hammer, Oppenheimer was the scalpel. Where Groves was blunt, Oppenheimer was poetic. He was a man who seemed to have mastered everything he touched. He had learned Dutch in just 6 weeks to give a lecture in the Netherlands. He read the Bhagavad Gita, the Hindu scripture, in its original Sanskrit. He was a charismatic leader, a magnetic teacher who drew the best and brightest young minds to him like a magnet draws iron filings. But he was also a security risk, a massive one. His wife had been a member of the Communist Party. His brother was a member. Many of his closest friends and associates had known communist sympathies. In the paranoid atmosphere of wartime, this should have been an immediate disqualification. FBI agents followed him. His phone was tapped. His mail was opened. Every security advisor on the project screamed that Oppenheimer was the wrong choice. Groves, however, saw past the security reports. He saw an ambition in Oppenheimer that mirrored his own. A deep, burning desire to be the first, to succeed where others might fail. He saw a man who understood not just the science, but the monumental scope of the task. During their first meeting, Oppenheimer spoke not just of physics, but of the need for a central laboratory. A single, isolated place where all the great minds could come together, away from the distractions and dangers of the outside world, to focus on one single goal, a scientific monastery dedicated to a terrible new god. Groves listened, and he agreed. He overruled every security objection. He put his own career on the line. He chose Oppenheimer, and in that moment, the two poles of the Manhattan Project were established. The pragmatic, unyielding military commander and the brilliant, tormented scientific visionary. An unlikely partnership bound together by a shared, secret purpose. A purpose that would demand the creation of a secret empire. The scale of this empire is almost impossible to comprehend, even now. Imagine trying to hide an elephant in a living room. Now imagine trying to hide an entire new American industry, one larger than the entire U.S. auto industry at the time. An industry that cost $2 billion, a staggering sum in the 1940s, equivalent to tens of billions today, and all of it had to be done in absolute total secrecy. Secrecy became the project's lifeblood. It was a religion. The central principle was called compartmentalization, a grim, bureaucratic word for a simple, brutal idea. You only knew what you needed to know to do your job. Nothing more. A chemist working on one part of the process would have no idea what the physicist in the next building was doing. A construction worker pouring concrete for a massive, windowless building would be told it was for a new kind of paper mill. A woman operating a vast control panel, watching dials and flipping switches, would only know that if the needle on a certain gauge moved into the red, she had to follow a specific procedure. She had no idea she was enriching uranium. Entire families moved to these secret sites, living in prefabricated houses in communities that appeared, almost overnight, in the middle of nowhere. Their mail was censored. Their conversations were monitored. They were forbidden from discussing their work with anyone, even with their own spouses. Signs everywhere reminded them, what you see here, what you do here, what you hear here, when you leave here, let it stay here. The silence was a tangible thing, a constant pressure on everyone involved. To find the right locations for this secret empire, the army scoured the country. They needed places that were isolated, places with access to huge amounts of water and electricity, places that could be easily secured and hidden from view. They found the first in the rolling hills of eastern Tennessee, a sprawling, 59,000-acre plot of land, nestled in a valley. The government simply arrived one day, condemned the farms and homes of 1,000 families, giving them a few weeks to pack up and leave the land their families had worked for generations. And on that land, they built a city that, at its peak, would hold 75,000 people. A city with schools, hospitals, theaters, and bowling alleys. A city that appeared on no map. It was officially called the Clinton Engineer Works. The people who lived there called it Oak Ridge. It was here that the massive, power-hungry factories were built to separate the rare, fissile isotope uranium-235 from natural uranium. One of these plants, K-25, was, at the time, the largest building in the world under a single roof. A U-shaped structure 1/2 mile long and 400 feet wide. Inside, thousands of workers, mostly young women, tended to the complex and delicate machinery, completely unaware of the true nature of the material they were producing. They found the second location in a desolate, windswept stretch of desert in Washington state, along the Columbia River. Here, they built the Hanford Engineer Works. This place was different. It was even more isolated, more industrial, more foreboding. Its purpose was singular: to produce plutonium. Here, they built the world's first full-scale nuclear reactors. Colossal cubes of graphite and uranium, cooled by the constant flow of river water. The work was dangerous, the science even more experimental than at Oak Ridge. The landscape was dominated by the towering reactors and the massive, ominous chemical separation plants known as canyons. These were concrete chasms, 800 feet long, where robotic cranes would process the intensely radioactive fuel rods, all operated by remote control. The few people who worked there were creating an element that had barely existed on Earth before, a substance of terrifying power. Before we delve deeper into the lives of those who inhabited these secret cities, if these stories of history's shadows help quiet your mind, please consider subscribing to The Dark Historian. Your support allows us to continue unearthing these forgotten tales. Now, back to the high desert of New Mexico. While Oak Ridge and Hanford were the industrial heart of the project, its mind, its soul, was to be located somewhere else entirely. This was Oppenheimer's vision, the central laboratory. For this, they needed a place of true isolation, a place that was both secure and inspiring. Oppenheimer, who loved the American Southwest, knew just the place, a remote mesa in the mountains of northern New Mexico. It was home to the Los Alamos Ranch School, a private institution where wealthy boys were taught riding and outdoor skills alongside their academics. It was beautiful, rugged, and almost completely inaccessible. It was perfect. Once again, the government moved in. The school was closed, and the army descended. Construction began at a frantic pace. What was once a quiet school became a muddy, chaotic construction site, and then a fortified town. A fence went up around the entire mesa. Guard towers were erected. This was Site Y, Los Alamos. Here, the greatest scientific minds in the world began to gather. Nobel laureates, brilliant young physicists, chemists, and engineers. They were recruited in secret, often told only that they were needed for a vital war project. They left their university posts, their comfortable lives, and brought their families to live in a hastily built, constantly expanding town behind a barbed wire fence. Their driver's licenses listed their names as numbers. Their mailing address was a post office box in Santa Fe. To the outside world, they had simply vanished. This was the strange world that Leslie Groves and Robert Oppenheimer built. A secret, parallel America. A network of hidden cities and colossal factories, all working in concert towards a single unseen goal. An industrial machine of unprecedented scale, run by a military man who demanded results, and a scientific brain trust of unprecedented genius, led by a poet of physics. They had the money, they had the manpower, they had the materials, they had the minds. They had created an entire civilization in the shadows, a world built on secrets and driven by fear of what the enemy might be building, and a growing, unspoken fear of what they themselves were about to create. The foundations had been laid. The machine was running. On a lonely mesa in New Mexico, in the sprawling factories of Tennessee, and in the radioactive canyons of Washington State, the work was underway. The quiet hum of theory was being drowned out by the roar of industry. The countdown had begun, not with a ticking clock, but with the turning of gears, the pouring of concrete, and the splitting of the first atom in a controlled reaction, deep beneath a football stadium in Chicago. The science was proving to be possible. Now, it had to be made practical. It had to be made into a weapon. And in the high, thin air of Los Alamos, the architects of this new fire were gathering, ready to begin the final, most terrible phase of their work. The real work was just beginning. The work was just beginning. And the place where it would happen felt like the edge of the world. Imagine arriving there for the first time. You've been on a train for days, crossing a continent, with sealed orders. You get off at a dusty, forgotten stop in the New Mexico desert. A car is waiting. It takes you up a winding, treacherous road, climbing higher and higher into the Jemez Mountains. The air gets thin, the light gets sharp, and then you arrive, not at a city, but a construction site, a chaotic, muddy sprawl on a high mesa, surrounded by canyons and pine forests. This was Los Alamos. There was no town. Not really. It was a secret, hastily thrown together. A place that did not exist on any map. The streets were unpaved rivers of mud. The buildings were flimsy, prefabricated structures, all painted a drab olive green. The hammering was constant, a relentless soundtrack to your new life, and the security was absolute. A high fence ringed the entire mesa. Armed guards patrolled its perimeter. Your mail, both incoming and outgoing, would be read by sensors. Your phone calls, if you were ever allowed to make one, would be monitored. Your identity, your very name to the outside world, was erased. You now lived at P.O. Box 1663, Santa Fe. That was all. And for this, you had left behind a prestigious university post, a comfortable life, everything you knew. Why? Because you were one of a few hundred people on the planet who could help answer a terrifying question. A question whispered in the highest corridors of power. A question that could win or lose the entire war. The minds gathered there were staggering. A greater collection of scientific intellect had never been assembled in one place. Nobel laureates walked the muddy streets alongside brilliant young physicists, barely out of their 20s. There was Enrico Fermi, the quiet Italian genius who had already achieved the first self-sustaining nuclear chain reaction. Hans Bethe, the unflappable head of the theoretical division, a man whose mind could move through complex physics like a grandmaster playing chess. The mercurial Edward Teller, whose ambitions already burned beyond the current project. And then there were the young guns, The brilliant, mischievous Richard Feynman, who treated the entire top-secret project with a kind of playful irreverence, cracking safes for fun and confounding the military security at every turn. And holding this volatile, brilliant, and eccentric collection of egos together was J. Robert Oppenheimer. He was a paradox, a man of immense culture who loved poetry and philosophy, now tasked with creating the most brutal weapon in history. He was thin, almost fragile, with piercing blue eyes and a constant chain of cigarettes. But he possessed a unique kind of genius. He wasn't necessarily the best physicist on the Mesa Many. There were his superiors in pure calculation. But Oppenheimer understood them all. He could speak the language of theoretical physics, of chemistry, of metallurgy, of engineering. He could walk from a blackboard covered in equations about neutron cross-sections to a meeting about the procurement of sheet metal and understand both conversations perfectly. He drove them. He inspired them. He understood that this monumental task was not just an engineering problem. It was a crucible of human intellect and will. He fostered an atmosphere of intense, open debate. Everything was questioned. Every assumption was challenged. Seminars and colloquiums ran day and night. The real work wasn't done in tidy offices. It was done on blackboards, hundreds of them, covered in a snowstorm of chalk dust. It was done over coffee in the mess hall. It was done on long walks through the pine forests, the thin mountain air a stark contrast to the dense, heavy problems they were trying to solve. The central problem was something they called critical mass. Think of it this way. Imagine you have a single, unstable atom of uranium-235. If a stray neutron hits its nucleus, the atom will split, releasing a tremendous burst of energy. And in that split, it also releases 2 or 3 more neutrons. Now, if those new neutrons have nothing to hit, they just fly off into space. Nothing happens. A tiny, insignificant pop. But what if you have a lump of this uranium, a sphere of it? Now, when that first atom splits, the neutrons it releases are more likely to hit other uranium atoms. And those atoms split, releasing more neutrons, which hit more atoms, which split, which release more neutrons. A chain reaction. The question was, how big does that lump need to be? Too small, and most of the neutrons escape before they can hit anything. The reaction fizzles out. A dud. Too big and, well, no one was entirely sure. The numbers they were calculating were astronomical. But they knew it would be a release of energy on a scale never before witnessed. That specific size, that tipping point between a fizzle and a firestorm, was the critical mass. Calculating it was a nightmare. It involved a new field of physics, dealing with the esoteric behavior of neutrons. They argued for weeks, for months, filling blackboards with equations, running primitive calculations on clunky IBM machines that filled entire rooms. Every variable had to be perfect. The purity of the uranium, the shape of the sphere, the speed of the neutrons. A mistake of a few percentage points could be the difference between a functional weapon and a useless, radioactive paperweight. Or worse, a weapon that detonated prematurely, killing everyone working on it. The pressure was immense. They were working in the dark, on a path no one had ever walked, with the fate of the world resting on the accuracy of their chalk marks. This constant state of high-stakes problem-solving took a toll, a silent grinding down of nerves and spirit. The days were long, the nights often sleepless, filled with numbers and doubts. Before we delve into the personal cost of this secret city and the strange society that formed in the shadow of the bomb, if you find these late-night histories a welcome companion in the quiet hours, please consider subscribing to The Dark Historian. It is your support that helps us continue to unearth these stories for you. Now, back to the Mesa, where another, Even more complex problem was beginning to emerge. The problem was plutonium. Uranium was proving incredibly difficult to enrich in the quantities they needed. But at the secret facilities in Hanford, Washington, they were beginning to produce a brand new, man-made element, plutonium. And plutonium, they discovered, was even better for a chain reaction. It was far more unstable. Its critical mass was smaller. It was, in short, the perfect fuel for their weapon. But it had a fatal flaw, a contamination. A particular isotope of plutonium was so unstable that it was constantly spitting out stray neutrons all on its own. It had a high rate of spontaneous fission. Why was this a problem? It came down to the design of the bomb itself. For the uranium bomb, the plan was relatively simple. They called it the gun-type device. You take two pieces of uranium, both below critical mass. You put one at the end of a long tube, a gun barrel. You put the other at the opposite end, as a bullet. Then, you use conventional explosives to fire the uranium bullet down the barrel at immense speed. The two pieces slam together, form a critical mass, and the chain reaction begins. Simple, brutally, elegantly simple. But you couldn't do that with plutonium. The plutonium bullet would start its chain reaction the instant it began moving down the barrel. The stray neutrons from that contaminant would set it off far too early. The result would be a fizzle. The weapon would blow itself apart with the force of a few tons of TNT, not the tens of thousands they were aiming for. A messy, radioactive failure. The gun method was a dead end for plutonium. The entire project seemed to be on the verge of collapse. All the time and resources spent creating this new element looked like a waste. It was a dark time on the mesa. The mood was grim. All their work, all their sacrifice, seemed to be leading to a dead end. But in that desperation, a radical, almost unthinkable idea began to take shape. An idea so complex, so audacious, it bordered on science fiction. The idea was implosion. If you can't bring the plutonium to critical mass slowly, by shooting one piece into another, what if you could do it instantaneously, from all directions at once? Picture a solid sphere of plutonium, just smaller than a grapefruit. Now, surround that sphere with a perfectly engineered shell of high explosives. The challenge is to detonate all of those explosives at the exact same microsecond. Not close. Exact. The resulting shockwave would have to be perfectly symmetrical, a uniform, crushing pressure moving inward at thousands of miles per hour. It would squeeze the plutonium sphere, compressing it, increasing its density. For a fraction of a second, you would crush that grapefruit-sized ball of metal into something the size of a marble. In that moment of extreme density, it would become supercritical. The chain reaction would begin, and the energy release would be catastrophic. The sheer difficulty of this is hard to overstate. It was a problem of brutal, hands-on engineering, not elegant theory. They had to invent an entirely new science of explosives. They needed detonators that could fire with a precision never before imagined. They had to shape the explosive charges into complex lenses that would focus the blast wave inward like light through a camera lens. Any imperfection, any asymmetry in the shockwave, and the plutonium core would be squeezed unevenly, squirting out the side like toothpaste from a tube. Another fizzle. This was the new heart of the project, the implosion problem, and it consumed Los Alamos. While the scientists wrestled with these cosmic questions, a strange and surreal society was taking root around them. More than 6,000 people eventually lived on the mesa, a secret town of scientists, engineers, technicians, soldiers, and their families. It was a place of jarring contrasts. Men who spent their days calculating the end of the world would go home to cramped apartments and help their children with their homework. Life was both primitive and privileged. there was a constant shortage of water. The housing was usado shoddy, the walls so thin you could hear every conversation next door. Yet, because of the high-priority nature of the project, they had access to goods that were strictly rationed in the rest of the country. Fresh meat, eggs, chocolate. A whole generation of children was born there. Their birth certificates listed their place of birth simply as P.O., Box 1663. They grew up in a world ringed by a fence, a world where certain words were forbidden, where their father's work was a complete mystery. They knew only that it was important and that it was secret. The wives of Los Alamos lived in a particularly strange limbo. They were isolated, sworn to secrecy about a secret they didn't even know. They were told not to use the words physicist or bomb. They were instructed to tell outsiders. Their husbands were engineers. They organized their lives around the rhythms of the top secret laboratory. They formed book clubs, put on plays, organized square dances and ski trips. They tried to carve out a semblance of normal life in the most abnormal place on Earth. But the tension was always there, just beneath the surface. The constant secrecy bred suspicion and gossip. The isolation and confinement wore on people. Some called it concentration camp fever. You were surrounded by the most interesting people in the world, but you could never, ever leave without permission. The only view was of the stunning, indifferent beauty of the New Mexico landscape. And through it all, the work went on. 6 days a week, often 7. The lights in the technical areas burned all night. The sound of explosions echoed from remote canyons, where they tested the explosive lenses for the implosion device. The project was a living thing, a hungry beast that consumed time, resources, and the very lives of those who served it. They were racing. But who were they racing against? They all believed they were in a desperate race with Nazi Germany. The fear that Heisenberg and the German physicists would build a bomb first was the primary motivation, the moral justification for their work. It allowed them to compartmentalize, to focus on the technical problems in front of them without dwelling too much on the ultimate consequences. If we don't do this, they told themselves, someone far worse will. But they were racing against themselves too, against the limits of their own knowledge. They were pushing into a new, terrifying frontier of science. Every day brought new problems, new dead ends, new reasons to believe the whole thing was impossible. And every day, they would gather again around the blackboards, pick up the chalk, and try once more. The city on the hill, the secret on the mesa, was a machine for solving an impossible problem. It stripped away old identities and forged new ones. It turned academics into weapons designers. It turned quiet family men into the keepers of a secret that could scorch the sky. The theoretical work was hardening now, moving from the realm of chalk dust and abstract equations into the cold, hard reality of machine metal and chemical explosives. The monster was beginning to take shape, and soon they would have to find out if it would actually work. They would have to test it. But a test of what, exactly? When you imagine the bomb, you probably picture a single object, a single idea. But that's not how it was. In the minds of the physicists at Los Alamos, it was not one bomb, but two rival concepts, two entirely different paths to the same terrible destination. One was a study in brutal simplicity, the other a nightmare of impossible complexity. One was a bullet, the other a collapsing star. To understand the story of what was about to happen in the desert, you have to understand these two ideas, because one of them was considered a sure thing. So sure, in fact, they didn't even believe it needed a full test. The other was so radical, so close to the edge of known physics, that no one, not even its creators, knew if it would work at all. It might just be the most expensive dud in history. This is the story of two parallel paths, two different keys designed to unlock the same atom. Let's start with the simple one. The bullet. The scientists called it the gun-type device, and the name is almost perfectly literal. Imagine a cannon. At one end, you have a target. At the other, you have a projectile. The target and the projectile are made of a very special kind of uranium. Uranium-235. On their own, they are subcritical. That's the key word. Subcritical. They are warm with radiation, dangerous to be near for too long, but stable. They will not explode. They are like two halves of a switch, waiting to be closed. The bomb's mechanism was designed to do just that, to close the switch with brute force. Inside a long metal tube, a carefully machined slug of uranium-235 would sit at one end. At the other, a larger, hollowed-out sphere of the same material waited. When the time came, a conventional explosive, like cordite, would detonate behind the slug. It would fire the uranium bullet down the barrel at over 1,000 feet per second. In the tiny fraction of a second it took to travel that short distance, the bullet would slam into the target sphere. The two subcritical masses would become one, and in that instant, everything would change. They would become supercritical, a runaway chain reaction. The first stray neutron would strike a uranium nucleus, splitting it and releasing energy, along with 2 or 3 more neutrons. Those neutrons would strike other nuclei, which would split, releasing more energy and more neutrons. It's a cascade, a flood. 2 becomes 4, 4 becomes 8, 16, 32, growing exponentially in a space of time, too small for the human mind to truly grasp. In less than a microsecond, a billion fissions. The result is a release of energy on a scale that, until then, had only existed in the heart of the sun. That was the gun-type bomb. Simple, mechanical, reliable. The physics were well understood. The engineering was for the brilliant minds at Los Alamos, relatively straightforward. They knew it would work. Their confidence was absolute. But here's the thing. Knowing how to build the cannon is one thing. Getting the cannonball is another entirely. The problem wasn't the design. The problem was the fuel. The fuel was uranium-235. And uranium-235 is fantastically, absurdly rare. You have to picture the natural world. When miners dig uranium ore out of the ground, that rock is almost entirely made of a different kind of uranium. Uranium-238. For every 1,000 uranium atoms in that ore, 993 of them are U-238. It's heavy, stable, useless for a bomb. Only 7 atoms out of that 1,000 are the one they needed. The fissile, unstable, perfect isotope, U-235. They are chemically identical. You can't separate them with a solvent or a reagent. They behave the same way. The only difference between them is a tiny, almost imperceptible variation in weight. The U-238 atom has 3 more neutrons, making it just a fraction of a percent heavier than its volatile cousin. And that tiny difference was the foundation of the largest industrial project in human history. To get the fuel for their simple gun, they had to build a secret city. In the quiet valleys of Tennessee, a place chosen for its isolation and its access to massive amounts of hydroelectric power, they built a complex called Oak Ridge. It was a city that appeared from nothing, swelling to a population of 75,000 people who lived and worked behind a wall of total secrecy. Most of them had no idea what they were working on. They only knew their part. They were told it was for the war effort, and that was enough. Inside vast, windowless buildings, the size of which the world had never seen, they built the machines to perform this impossible task. One of the primary methods was called electromagnetic separation. Try to imagine it. A series of massive machines called calatrons. each one a gigantic magnet, wound with thousands of tons of silver wiring, because copper was needed for the war. Inside a vacuum chamber, they would vaporize the raw uranium and use powerful magnetic fields to bend the stream of atoms. Because U-238 was slightly heavier, it wouldn't bend as sharply as the lighter U-235. The two streams would separate, ever so slightly. At the other end, two collection bins would sit, waiting. One would catch the unwanted U-238. The other, with agonizing slowness, would collect the precious, bomb-grade U-235. The process was horribly inefficient. The magnets drew staggering amounts of power. The machines were constantly breaking down. For every 10,000 atoms that entered the stream, only one might end up in the correct collection bin. They would run the material through the process again, and again, and again, each time making it a little bit richer, a little purer. It was like trying to isolate a single grain of special sand from a mile-long beach, and you can only do it by blowing on the sand and hoping the lighter grain travels a millimeter farther. This was the great paradox of the gun-type bomb, the one they would later name Little Boy. The concept was as simple as a rifle, but the bullet for that rifle required a secret city, the power consumption of a major metropolis, and the labor of tens of thousands of people working around the clock for years, just to produce a few kilograms of the right material. Their confidence in the design was so high that they planned to simply build it, ship it, and use it. A test would be a waste of this impossibly precious material. They only had enough for one, but that was just one path, the simple path. The other path was born of a different element, an element that didn't even exist in nature, a man-made substance forged in the heart of a nuclear reactor, plutonium. While the monumental effort to separate uranium was underway in Tennessee, another secret city was being built in the desolate plains of Washington state. This was the Hanford site. Here, they built the world's first industrial-scale nuclear reactors. Massive cubes of graphite and uranium, cooled by the constant flow of the Columbia River. Inside these reactors, a kind of modern alchemy took place. The abundant, useless uranium-238, when bombarded by neutrons, would absorb one. It would become unstable. It would decay. And in that process of decay, it would transform into a new element, element 94, plutonium-239. And get this, plutonium was even better than uranium for a bomb. It was more fissile, more unstable. You needed less of it to reach critical mass. And, best of all, it could be created in a reactor and then separated out chemically. It was a different element after all. No need for the brute force magnetic separation of Oak Ridge. In theory, it was much, much easier to produce in large quantities. Plutonium was the shortcut. It was the elegant solution. The project leaders, like General Groves, saw it as the future, the primary path to the weapon. There was just one problem, a fatal flaw. Plutonium, it turned out, was poisonously radioactive, and it was contaminated. The very process that created it also created an unwanted isotope, plutonium-240, and this isotope was a troublemaker. It was highly unstable, constantly spitting out stray neutrons. Spontaneously. Why did that matter? Think back to the gun-type bomb, the simple cannon. It works because the two pieces of uranium come together very, very fast. The chain reaction has to start at the precise moment of maximum compression. But if you tried to build a gun-type bomb with this new, dirty plutonium, it would be a catastrophe. As the plutonium bullet sped down the barrel towards its target, the stray neutrons from the plutonium-240 contaminant would start the chain reaction too early, before the two pieces were fully joined. Before they reached that point of maximum density, The result wouldn't be a devastating explosion. It would be a fizzle. The initial energy release would blow the bomb apart before the chain reaction could truly get going. It would be a radiological mess, a dud, a failure. The simple, reliable gun design was completely useless for plutonium. The shortcut had led to a dead end. The news hit Los Alamos like a physical blow in the summer of 1944. The entire Hanford facility, a project of unbelievable expense and scale, was built to produce fuel for a bomb design that would not work. All that effort, all that time, wasted. Panic began to set in. But in the midst of that panic, a small group of physicists, led by a man named Seth Nettermeyer, had been working on a different idea, a theory that was considered by most to be a scientific backwater, an elegant but impractical fantasy. The idea was called implosion. If you can't bring the fuel together fast enough with a gun, what if you could do it a different way? What if you started with a single, subcritical sphere of plutonium, and what if you could somehow squeeze it from all sides, at the exact same time, with such unimaginable force that you crushed the atoms themselves closer together? If you could do that, you could increase its density, and by increasing its density, you could force it to go supercritical. Imagine holding a grapefruit in your hands. Now imagine you could squeeze it from every single point on its surface, simultaneously, with a pressure of millions of pounds per square inch. Squeeze it so hard and so fast that it collapses in on itself to the size of a marble. That was the theory of implosion. It was a beautiful idea, and it was a complete nightmare to engineer. How do you create that perfectly symmetrical, perfectly timed squeeze? The answer was conventional explosives. You would have to surround the plutonium sphere, the pit, with a layer of high explosives. But you couldn't just set them off. That would create an uneven shock wave, pushing the plutonium around like a wet sponge, not compressing it. You needed to shape the blast, to focus it, to turn a chaotic, outward explosion into a perfect, inward-moving spherical shockwave. The solution they came up with was one of the most complex and ingenious pieces of wartime engineering. They called them explosive lenses. Think of how a glass lens focuses light to a single point. These explosive lenses would do the same thing, but with a shockwave. They were made of a complex arrangement of two different kinds of explosives, a fast-burning explosive and a slow-burning one. By carefully shaping these materials into precise wedges, they could sculpture the detonation wave. When detonated from the outside, the shock wave would travel faster through the fast explosive and slower through the slow one. The carefully calculated geometry would bend and shape the wave, directing it inward. They would need to arrange 32 of these explosive lens assemblies around the plutonium pit, forming a perfect sphere. A shell of explosives surrounding a tamper of uranium, which in turn surrounded the small, warm, deadly plutonium core. And then came the hardest part of all. All 32 of those lenses had to detonate at the exact same time. Not close. Exact. If one went off even a millionth of a second before the others, the whole assembly would be ruined. The shockwave would be lopsided. The plutonium pit would be squeezed out the side like toothpaste from a tube. Another fizzle, another failure. The challenge was almost insurmountable. They had to invent entirely new technology. High-speed electronic detonators, called exploding bridge-wire detonators, that could trigger all 32 charges within nanoseconds of each other. They had to invent new high-speed cameras and X-ray technologies just to get a fleeting glimpse of what was happening during their tests with dummy cores. For months, the implosion team at Los Alamos was met with failure after failure. The X-rays of their test compressions showed lopsided, distorted messes. The calculations were mind-bendingly complex. Many on the project believed it was impossible. a dead end. But they had no choice. The simple gun method was reserved for the small amount of uranium they were painstakingly producing at Oak Ridge, but the massive plutonium factory at Hanford was now churning out fuel. All of it useless unless the implosion device could be perfected. The entire weight of the Manhattan Project shifted. The focus, the resources, the best minds all were thrown at the problem of implosion. Oppenheimer reorganized the entire laboratory to tackle the challenge. Brilliant chemists like George Kishiakowski, an expert in explosives, were brought in to perfect the explosive lenses, casting the volatile materials with the precision of a sculptor. You have to feel the pressure in that remote canyon lab. The war in Europe was drawing to a close, but the war in the Pacific was raging with unimaginable ferocity. The casualty estimates for a land invasion of Japan were staggering. Hundreds of thousands, maybe millions. They were in a race against time, a race against the enemy, and a race against the laws of physics themselves. So now you see the two paths. One, the gun-type bomb, little boy. Simple, reliable, almost guaranteed to work. But it was fueled by uranium-235, a material so difficult to produce that they would only have enough for a single weapon. There was no room for a test. The other, the implosion-type bomb, Fat Man, a highly complex, delicate, and completely unproven device. A scientific gamble of the highest order. But it was fueled by plutonium-239, which could be produced far more quickly. It was the weapon of the future, and it was a very big if. They could make it work. Everything now depended on solving the puzzle of the collapsing sphere. They had the plutonium, they had the theory. But theory is one thing, reality is another. Could they truly craft an explosion with the precision of a watchmaker? Could they time 32 detonations to the billionth of a second? Could they create a man-made star by crushing a piece of metal in on itself? No one knew for sure. The calculations said yes. The small-scale experiments were encouraging, but inconclusive. There was only one way to find out. Unlike the uranium bomb, this one was too uncertain, too radical to be used without proof. The risk of failure was too high. They couldn't just drop it and hope. They had to test it. They had to build one, take it out into a remote corner of the world, and press the button. They had to see with their own eyes if this impossible machine, this sphere of perfectly shaped explosives and man-made metal, would actually do what the numbers on the chalkboard promised. All their work, all the secret cities, all the intellectual force of a generation of scientists had come down to this single, terrifying question. Would the implosion bomb work? The answer would have to be found in a desolate stretch of New Mexico desert, a place they had already named, Jornada del Muerto, the journey of the dead man. It was a place named by ghosts, a dead man's journey, a stretch of New Mexico desert so barren, so unforgiving, that to cross it was to risk joining the sun-bleached bones of those who had failed before you. The air is thin here, and the silence is a physical presence. It is a silence that has existed for millennia, broken only by the whisper of the wind over sand and scrub, or the skittering of a lizard across hot rock. Into this ancient quiet, they brought the machine. They called it the gadget, a name so deliberately mundane, so bland, it felt like a desperate attempt to tame the thing, to make it feel ordinary. But there was nothing ordinary about it. A 5-foot sphere of steel, bristling with wires and detonators, cradling a core of plutonium no bigger than a piece of fruit. A dark, dense star of man-made metal, humming with a power that the universe had, until now, reserved for the hearts of suns. They placed the sphere at the top of a 100-foot steel tower, a lonely skeletal finger pointing at the sky. From a distance, it looked like a strange offering, an altar to some new, terrible god. And all around it, for miles, They built bunkers, concrete and earth dugouts, with thick quartz windows to peer through. Control rooms filled with the low hum of electronics, the smell of ozone, and the sharper, acrid scent of nervous sweat. This was Trinity, the culmination of years of work, of frantic calculations, of sleepless nights spent wrestling with equations that described the very fabric of reality. The brightest minds of a generation had been gathered, isolated, and given a single, monumental task: to build a weapon that could end a war, to build a weapon that could, perhaps, end all wars. But first, they had to see if it would even work. They had theory, they had mathematics, but they did not have certainty. There was a lingering fear, a whisper in the back of every mind. A small, but non-zero, chance that the chain reaction would not stop, that it would ignite the atmosphere itself, and in a single, searing flash, turn the entire planet to ash. A final, fatal experiment. The test was scheduled for the early morning of July 16th, 1945. But the desert had other plans. As night fell, the sky, which had been clear and studded with 1 billion stars, began to boil. Clouds rolled in, thick and black. Lightning spiderwebbed across the horizon, followed by the low growl of thunder. Rain began to fall, a miserable, soaking drizzle that turned the desert floor to mud and threatened the delicate electronics of the gadget. You can picture the scene. J. Robert Oppenheimer, the scientific director, pacing in the main control bunker, a man who seemed to be made of little more than nervous energy, bone, and cigarette smoke. He was impossibly thin, his piercing blue eyes seeming to burn from within a face etched with exhaustion and worry. Every delay, every crackle of static over the radio, every gust of wind was a new torture. General Leslie Groves, the military head of the project, was the opposite. A man of immense physical presence and unshakable will, he wanted this test done. He had a schedule. A war was on. He saw the storm not as a sign, but as an inconvenience. The meteorologists were frantic, sending up weather balloons, reading charts, making predictions that changed by the hour. The launch was set for 4 a.m, then postponed. The tension in the bunkers became a thick, suffocating thing. Men sat at their consoles, checking dials that read 0. They spoke in low murmurs. They tried to make jokes that fell flat. They drank coffee that had long gone stale. They were waiting. Waiting for the weather. Waiting for a decision. Waiting to see if they were about to become creators, or the authors of their own extinction. Finally, a break. The meteorologist, Jack Hubbard, gave a forecast. Not a promise, but a window. The storm should pass by 5:30. Groves and Oppenheimer conferred. The decision was made. 5:30 a.m. The countdown would begin. Imagine the sound of the final announcements over the loudspeakers, echoing across the dark, wet desert. The flat, disembodied voice of the controller, cutting through the night. T-minus 45 minutes. A switch is thrown. Another. The arming party drives away from the tower at high speed, their headlights cutting lonely paths through the darkness. They are the last humans to be near the device. From now on, it is in the hands of electricity and timers. T-minus 20 minutes. In the observation bunkers, men prepare. They are given welder's glass to protect their eyes. They are told to lie on the ground, feet toward the blast, and to not look directly at it until the initial flash has passed. Some men, like the physicist Richard Feynman, disregard the order, choosing to watch from behind the windshield of a truck, convinced it would filter out the harmful ultraviolet rays. He wanted to see it, really see it. T-minus 10 minutes. The final sequence is automated. A master brain of switches and relays begins its work. There is nothing left for human hands to do but wait. Oppenheimer is in the control bunker, holding on to a post to steady himself. His face is a pale, drawn mask. Kenneth Bainbridge, the director of the test, stands beside him, his own face grim. He was the one who had chosen this spot, this dead man's journey, for their experiment. The irony was not lost on him. T-minus 60 seconds. The voice from the speakers now has a rhythmic, almost hypnotic quality. A siren begins to wail, a long, mournful cry across the desert. 50 seconds. 40. Men lie flat on the ground, their faces buried in their arms. Some are praying. Some are counting. Some are simply holding their breath. 30 seconds. The plutonium core is now unimaginably dense. The conventional explosives surrounding it are armed, ready to create the precise symmetrical implosion needed to start the chain reaction. 20 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. For an impossible heart-stopping moment there is nothing, just the pre-dawn darkness, the silence, the thought for a fraction of a second that it had failed. And then, light. It is not a flash, it is a creation. A sun blooms on the surface of the earth. A pinpoint of light expands into a hemisphere of pure, white-hot energy that consumes the darkness, erases the stars, and turns the night into a day brighter than any noon. It is a silent, searing light that washes over the observers miles away, a physical thing that you can feel on your skin. Even through closed eyelids, the light is blinding. It prints the bones of your hands onto the back of your retinas. The mountains, 30 miles away, are illuminated in perfect, stark detail, every rock and ravine etched in a light that should not exist. For several seconds, this silent spectacle continues. A growing, boiling ball of plasma, churning with impossible energies. It is beautiful. Terrifyingly, biblically beautiful. The colors shift from white to yellow, then to a deep, angry orange. It begins to rise, pulling a thick column of dust and debris with it. The steel tower that held the gadget is gone. Not bent, not broken. Vaporized. The desert sand beneath it is gone, fused by the heat into a glassy, radioactive green stone. They had done it. They had brought a star to Earth. And in that moment of terrible creation, the world was changed forever. Before we explore what that change truly meant for the men who made it, and for the rest of us, a brief pause. If you are finding this journey into our darker history, a welcome companion in the quiet hours, consider subscribing to The Dark Historian. It allows these stories to continue being told. Now, back to the silent desert and the thoughts of the man who had just become a destroyer of worlds. After the light came the sound. It traveled at its own, more leisurely pace. 30-40 seconds after the flash, the shockwave arrived. It was not just a sound. It was a physical blow. A deep, deafening roar that felt like the sky was being ripped apart. It slammed into the bunkers, shook the ground, and knocked men who were standing off their feet. It was the sound of the world's first nuclear explosion, the furious announcement that a new age had begun. The roar echoed off the distant mountains for a long time, a rolling thunder that refused to die. And as the sound finally faded, a new silence fell, a silence of awe, a silence of terror, a silence of profound, world-altering significance. The men slowly got to their feet. They lowered their welder's glass. They stared at the thing they had made. The fireball was now a column of roiling smoke and fire, climbing higher and higher into the atmosphere. It began to spread out at the top, forming the iconic, terrifying shape, the mushroom cloud. It glowed with an internal, hellish light, a mixture of pinks and purples and grays, like a cosmic bruise on the sky. It rose to 40,000 feet, a monument of dust and fission products, a tombstone for the world that had existed just moments before. In the control bunker, the tension shattered. Some men cheered. Some slapped each other on the back. They had succeeded. The impossible machine had worked. George Kishikowski, the explosives expert, who had bet a month's salary against $10 that the device would work, ran up to Oppenheimer to collect his money, a moment of gallows humor in the face of the apocalypse. But Oppenheimer did not cheer. He stood, still holding onto the post. His face, in the eerie glow, was a study in conflict. There was relief, yes. The immense, crushing weight of potential failure was gone. But there was something else in his eyes. Something darker. A look of profound and terrible understanding. Years later, he would recall what he was thinking in that moment. It wasn't a thought from science or from military strategy. It was a line of ancient scripture from the Hindu holy book, the Bhagavad Gita. He had been studying Sanskrit, finding a strange comfort in its ancient wisdom. In the text, the god Vishnu is trying to persuade a prince that he must do his duty. And to impress him, Vishnu reveals his multi-armed, divine form and says, "Now I am become death, the destroyer of worlds." That was it. That was the only language Oppenheimer could find to articulate the enormity of what they had just witnessed. He hadn't just overseen a successful experiment. He had become a force of nature. He had handed humanity the power of its own annihilation. He was the prince, being shown a terrible divine power. He was also Vishnu. He was the destroyer. Nearby, Kenneth Bainbridge, a practical, no-nonsense man, turned to Oppenheimer. His own face was pale, his voice low and heavy. He did not quote scripture. His words were simpler, more profane, and just as profound. "Oppie," he said, "now we are all sons of bitches." Each man processed the moment in his own way. Enrico Fermi, the brilliant Italian physicist, had, in a moment of pure scientific curiosity, dropped small pieces of paper into the air as the shockwave passed, using their displacement to make a surprisingly accurate, on-the-spot calculation of the bomb's yield. His mind, even in the face of this spectacle, immediately returned to the numbers. Others were simply stunned into silence. I. Rabbi described the sight as something out of a dream, a violation of nature. He said the experience gave him a new sense of foreboding, that humanity had become a threat to itself. General Groves's first thought was more pragmatic. The war is over, he thought. He saw not the philosophical implications, but the strategic ones. This light, this sound, this terrible cloud was a message to the Empire of Japan, a message that could not be ignored. He felt a surge of triumph. His $2 billion gamble had paid off, as the sun began to rise for real. Its gentle morning light seemed pale and insignificant compared to the false dawn they had created. The mushroom cloud began to drift and dissipate, spreading its invisible poison across the landscape. The scientists, the engineers, the soldiers began to pack up their equipment. They got into their cars and trucks and drove away from Ground Zero, their faces illuminated by the dashboard lights. They drove back towards Los Alamos, back towards civilization. But they were not the same men who had driven into the desert hours before. They had looked into the fire. They had seen the heart of a star made real on Earth. They had unleashed a power that could save them, or consume them utterly. The journey of the dead man was over. But a new journey, for all of humanity, under the shadow of this terrible, beautiful light, was just beginning. The silence of the desert would eventually return, but the silence of the world before Trinity was gone forever. And the sound of that explosion would continue to echo, louder and louder, down through the decades to come. That deafening roar in the New Mexico desert was not an end. It was a beginning, a signal, and that signal, traveling at the speed of information, crossed the Atlantic Ocean in an instant. It arrived not as a sound wave, but as a coded telegram landing on a desk in a fractured, defeated city, a city called Potsdam in Germany. Here, in the summer of 1945, the world was being remade. The war in Europe was over. The great and terrible Nazi machine had been broken, its cities turned to rubble, its leaders dead or in chains. But the air was not one of pure celebration. It was thick with suspicion. You can almost feel it, The damp chill of a European summer, the smell of coal smoke and wet stone from the bombed-out buildings nearby. Here, the victors gathered to draw new lines on the map, to decide the fate of nations. They called themselves the Big Three. There was the old lion, Winston Churchill, though he would soon be replaced by a quieter man named Clement Attlee after a surprise election back home. There was the man of steel, Joseph Stalin, his eyes holding the cold, hard knowledge of 20 million Soviet dead and a deep, abiding paranoia. And then there was the new man, the unexpected man, Harry S. Truman. Just a few months before, he was the vice president, a former senator from Missouri, largely kept in the dark about the war's deepest secrets. Then, Franklin Roosevelt died, and the entire weight of the world was dropped onto his shoulders. Imagine that. One day you are a heartbeat away from the presidency, and the next you are the president. You are the commander-in-chief, and you learn that for years, a secret project. A project so vast it was like a hidden nation unto itself, has been building a weapon that can harness the power of the sun. A weapon that can erase a city in the blink of an eye. Truman knew nothing of the Manhattan Project before he took the oath of office. Now, in a palace just outside the ruins of Berlin, he held its terrible secret in his mind, and he had to decide what to do with it. This is where the story of the bomb leaves the realm of physics and enters the dark, complicated world of human choice. It leaves the laboratory and enters the mind of a single man sitting in a room thousands of miles from home, holding the power of a god he never asked for. The war in the Pacific was still raging. Raging is too small a word. It was a meat grinder, an inferno. The Japanese Empire, though beaten back, was refusing to break. The fighting grew more ferocious with every island taken. Places like Iwo Jima and Okinawa were not just battles, they were previews of hell. They were places where soldiers used flamethrowers to clear caves filled with defenders who would fight to the last man, woman, and child. Places where thousands of pilots deliberately flew their planes into American ships, the kamikaze, the divine wind, a weapon born of pure desperation. The military planners in Washington had a name for the final act: Operation Downfall. The invasion of the Japanese home islands. It was a plan of staggering scale, a nightmare scenario that made D-Day look like a practice run. The projections were terrifying. The American military expected to suffer as many as 1 million casualties. 1 million killed, wounded, or missing. A number so large it's hard to even comprehend. To prepare for it, the United States government began manufacturing 500,000 Purple Heart medals, the award given to wounded soldiers. They made so many that they are still being issued today, from that same stockpile, to soldiers wounded in Iraq and Afghanistan. Think about that. The predicted cost of that one invasion was so high, we still haven't used up the medals minted for it. And the cost for Japan, far, far worse. The Japanese government was preparing for a final, suicidal defense they called Ketsugo. The plan was to arm the entire civilian population, every man, woman, and child. They were being trained to fight with bamboo spears, with kitchen knives, with ancient muskets. They were being told it was their sacred duty to meet the invaders on the beaches and die for the emperor. The military's own projections estimated that an invasion would cost Japan 10 million lives. 10 million, a nation bled white. This was the choice laid on Truman's desk in Potsdam. Option A, Operation Downfall. A conventional, brutal, and bloody invasion that would certainly kill millions of people on both sides, dragging the war out for perhaps another year or more. A sea of blood and steel. Or Option B, the gadget, the thing from the desert, the unknown, a weapon that might end the war in days. But how? What would it do? To use it meant unleashing a power that no one truly understood, a power that scientists who had helped create it were now beginning to fear. Back in the United States, a quiet rebellion was stirring. Leo Szilard, the very man who had drafted the letter with Einstein that urged Roosevelt to build the bomb in the first place, was now horrified by the prospect of its use. He and dozens of other scientists at the Manhattan Project signed petitions, begging the president not to use the weapon on a civilian population without a clear warning and a chance to surrender. They argued that to unleash this power on a city would be a moral catastrophe. It would stain the name of the United States forever. It would open a Pandora's box, starting a nuclear arms race that could one day consume the world. Their pleas were intercepted. They were filed away. General Leslie Groves, the military head of the project, made sure these dissenting voices never reached the president's ears. To Groves, this was simple. The United States had spent $2 billion, an astronomical sum at the time, to build a weapon. The weapon was built to be used. The weapon would end the war. It was a cold military calculation. And so, in Potsdam, Truman sat with this knowledge, the numbers from his generals, the secret of the bomb, the ghosts of all the soldiers already dead, and the specter of the millions more who might be. Then, on July 16th, the coded message arrived. Operated on this morning. Diagnosis not yet complete, but results seem satisfactory and already exceed expectations. A short while later, a more detailed report came, describing the awesome, terrifying power of the Trinity test. The tower vaporized. The sand turned to glass, a light brighter than a dozen suns. Truman's entire demeanor changed. Those around him said he seemed like a new man. He had been wrestling with Stalin over the future of Eastern Europe, and now, suddenly, he held the ultimate trump card. He had an ace in the hole, as he put it. On July 24th, after a long, tense meeting, Truman walked over to Stalin. He tried to be casual about it. He mentioned, almost as an aside, that the United States had a new weapon of unusual destructive force. He watched the Soviet dictator for a reaction. Stalin just nodded. He said he was glad to hear it and hoped they would make good use of it against the Japanese. Truman thought. Stalin hadn't understood the significance of what he'd said. He was wrong. Stalin understood perfectly. Klaus Fuchs, a German physicist and a Soviet spy working deep inside the Manhattan Project at Los Alamos, had already given him all the details. Stalin knew all about the gadget. His seeming lack of interest was just a masterful piece of political theater. In that brief, quiet exchange, the Cold War truly began. The atomic age had its first secret handshake. With the decision to use the bomb now all but made, a new, colder question had to be answered. Where? A committee was formed. The Target Committee. It sounds so sterile, so bureaucratic. And it was. That's what makes it so chilling. Imagine a conference room in the Pentagon. Men in suits and uniforms, sitting around a polished wooden table. There are maps spread out before them. Photographs taken from reconnaissance planes. Weather charts. Population densities. They were not talking about people. They were talking about targets. They were not talking about homes, schools, and hospitals. They were talking about blast radiuses and firestorms. They came up with a set of criteria. The criteria for choosing a city to be annihilated. First, the target had to have military value. An army headquarters, a major port, or a large industrial center that was contributing to the war effort. This was essential for the public justification. It had to be framed as a military strike, not the wholesale slaughter of civilians. Second, and this is the one that sends a chill down your spine, the target must not have been seriously damaged by the conventional bombing raids that were already devastating Japan. The firebombing campaigns had already burned large sections of Tokyo and other cities to the ground. But for the first use of the atomic bomb, they wanted a virgin target. They needed to be able to accurately measure the weapon's power. They needed a clean slate, a pristine city, so they could see exactly what their new creation could do. The first atomic bombing was not just an act of war, it was also an experiment. Third, the target had to be large enough, a city of at least a few miles in diameter, so that the full, terrible scale of the bomb's power would be demonstrated. It had to be a spectacle, a demonstration so shocking, so final, that it would convince the Japanese high command that further resistance was impossible. Based on these criteria, they drew up a short list. The initial candidates were Kokura, home to one of Japan's largest munitions plants; Hiroshima, a major port and army headquarters; Yokohama, a key urban and industrial area; Niigata, a port with growing industrial facilities; and Kyoto, the ancient imperial capital of Japan, a city of over 1,000 years of history. It was home to hundreds of priceless, beautiful temples and shrines. It was the cultural and spiritual heart of the nation. It had been largely untouched by the war, and for that reason, it was a perfect target according to the committee's cold logic. It was on the list. It was a primary candidate. But then, something unexpected happened. An intervention. Secretary of War Henry Stimson, an old, respected statesman, had been to Kyoto before the war. He had walked its streets, admired its gardens, stood in its ancient temples. He knew what the city represented. He knew that its destruction would not just be a military act, but a cultural one. It would inflict a wound on the soul of Japan, so deep that it might never heal. It would, he argued, turn the Japanese people against the United States forever, making any post-war reconciliation impossible. Stimson fought for Kyoto. He went directly to President Truman. He argued his case not with military logic, but with an appeal to history, to culture, to a shared sense of humanity. He insisted that a city of such profound importance to all of civilization could not be destroyed, and Truman listened. He agreed. Kyoto was removed from the list. One man's memory, one man's appreciation for art and history, saved a city of 1 million people from nuclear fire. It is a strange and unsettling thought. The life and death of a city decided not by a grand strategy, but by a single conversation, a personal appeal. It shows you just how arbitrary the line between existence and oblivion had become. With Kyoto spared, the final list was set. The primary target was Hiroshima. It fit all the criteria perfectly. It was a major military headquarters for the entire southern region of Japan. It was a critical port and a hub of war industries. It had been almost completely untouched by previous bombing raids, and it had a unique geographical feature that made it especially attractive to the planners. The city sat in a flat river delta surrounded by hills. They believed these hills would act like a natural container, focusing the blast wave and the heat, maximizing the destructive effect. A perfect laboratory to demonstrate the bomb's power. The secondary targets were Kokura and Nagasaki. The plan was set. The machine was in motion. From Potsdam, the Allied leaders issued one final ultimatum to Japan, the Potsdam Declaration. It called for the unconditional surrender of all Japanese armed forces. It promised that the Japanese people would not be enslaved as a race or destroyed as a nation, but it warned that stern justice would be meted out to war criminals. The final sentence was a chilling promise, a direct consequence of the secret Truman now held. It said that if Japan did not surrender, it would face prompt and utter destruction. The world waited for Japan's response. The Japanese cabinet was divided. Some saw the writing on the wall and wanted to seek peace. The hardline military leaders refused. To them, unconditional surrender was unthinkable. It would mean the end of their warrior code, the disgrace of the nation, and the potential removal of their divine emperor. Their official response to the ultimatum was the word mokusatsu. It's a difficult word to translate. It can mean to ignore or to take no notice of, but it can also carry a stronger, more contemptuous meaning: to treat with silent contempt. To kill with silence. However it was meant, it was received by the Allies as a defiant rejection, a final refusal. For Truman, that was the final piece, the moral justification he needed. He had offered them a chance to surrender. They had refused. The military plans for Operation Downfall, with its millions of projected casualties, sat on one side of the scale. The bomb sat on the other. In his mind, the choice was now clear. The order was given. Far across the Pacific, on the island of Tinian, a B-29 bomber was being prepared. Its crew was running through their final checks. Inside the cavernous bomb bay, a new kind of weapon, nicknamed Little Boy, sat waiting. It was a dark, inert shape, a collection of steel and wires and precisely machined uranium. It held no malice. It was simply an object waiting for a command. The gears of history were turning. The long, slow countdown that had begun in the laboratories of Europe, that had echoed across the desert of New Mexico, was now reaching its final seconds. The sky over Hiroshima was still dark and quiet. Its people were asleep. They had no idea that they were the subjects of a global experiment. They had no idea that their city had been chosen. They had no idea that a terrible, man-made sun was on its way to dawn. The sky over Hiroshima on the morning of August 6, 1945, was a brilliant, cloudless blue, a perfect summer sky. Below, the city was waking up, not to peace, but to the familiar rhythms of a nation deep in a war it was losing. Children were heading out to help clear fire breaks, a grim but necessary task in a city made of wood and paper. Shopkeepers were rolling up their shutters. Streetcars rattled along their tracks, carrying workers to factories that still hummed with the effort of a desperate defense. An air raid siren had sounded earlier, around 7 a.m., but it was a common occurrence. A single American plane, a weather scout, was spotted. The all-clear was given a little after 7:30. People relaxed. It was just one plane. A lone B-29, nicknamed the Straight Flush, was no cause for panic. So they went about their morning. Under that perfect, empty sky, they felt a sense of relief, a small return to normalcy. They did not know that the weather plane's report back to its command was simple and chilling. Cloud cover less than 3/10 at all altitudes. Advice bomb primary. The primary target was Hiroshima. The perfect sky was not a blessing. It was a death sentence. Far above, another silver shape was cutting through the thin, cold air. This was the Enola Gay, a B-29 superfortress piloted by Colonel Paul Tibbets. For 6 hours, he and his crew had flown from the island of Tinian, a tiny speck in the vast Pacific. Their journey was smooth, almost serene. Inside the pressurized cabin, there was a strange quiet, a professional calm. Each man had a job to do. Tibbets focused on the controls. The navigator, Theodore Van Kirk, ensuring they arrived at the precise coordinates. The bombardier, Major Thomas Farabee, preparing to peer through his Norden bomb sight. And in the belly of their silver bird, a monster slept. They called it Little Boy, a 10-foot-long, 9,700-pound cylinder of dark, gunmetal gray steel. It didn't look like a harbinger of a new age. It looked like an oversized piece of industrial plumbing, but inside its simple casing was a terrifyingly elegant piece of physics. A carefully machined uranium-235 projectile aimed at a uranium-235 target. A gun? designed to fire one piece of uranium into another, and in doing so, to start a fire that had never before been seen on Earth. For most of the flight, the bomb was unarmed. It was too dangerous to take off with a live atomic device. A crash on the runway could have vaporized the entire island base. So, shortly after takeoff, in the dim light of the bomb bay, Navy Captain William Deke Parsons performed the final assembly. It was a delicate, nerve-wracking task. With the plane cruising thousands of feet over the dark ocean, he carefully inserted the bags of cordite explosive and connected the firing circuits. One slip, one jolt of unexpected turbulence, and the story could have ended right there. But there were no slips. The monster was now awake. As they approached the Japanese coast, the crew put on heavy, dark welding goggles. A strange precaution. What kind of light were they expecting? They had been briefed, of course. They had been told about the flash, the power. But a briefing is just words. How can you truly describe the birth of a star? At 8:09 a.m. local time, the air raid sirens in Hiroshima began to wail again. 2 more B-29s had been spotted, flanking the Enola Gay. But still, there was no widespread panic. 3 planes. It was likely just another reconnaissance mission. The Japanese had grown used to the sight of the high-flying bombers. They passed over so high, so untouchable, that they seemed almost disconnected from the war on the ground. People looked up, shielding their eyes against the morning sun, and saw 3 tiny silver glints in the vast blue. Then, most looked down again and went on with their day. Inside the Enola Gay, Thomas Farabee was looking down too. Through his bomb sight, the city of Hiroshima resolved into a clear, detailed map. He could see the rivers, the streets, the buildings, and he could see his target, a distinctive, T-shaped bridge called the Aoi Bridge, which crossed the Oder River right in the heart of the city. It was an unmistakable landmark, the perfect bullseye. At 8:15 a.m. plus 17 seconds, the bomb bay doors of the Enola Gay slid open, exposing the dark cylinder to the sky. "I have it," Farabee said over the intercom. His voice was steady. The crosshairs of his sight were locked on the Aoi Bridge. A tone began to sound in his headset, the signal that the release point was approaching. Tibbets kept the plane perfectly steady. "It's yours," he said, and then the tone stopped. The bomb was released. The plane, suddenly almost 10,000 pounds lighter, lurched upwards, a sensation of relief, of release. Tibbets immediately threw the bomber into a steep, 155-degree diving turn, a maneuver he had practiced again and again over the salt flats of Utah. They needed to put as much distance as possible between themselves and the point of detonation. They had 43 seconds. Below, the bomb fell. It tumbled for a moment before its tail fins caught the air, stabilizing it into a silent, graceful arc. To anyone on the ground who happened to look up at just the right moment, it would have been a curious sight. A single, dark object, gleaming in the morning sun, descending from the heavens. A strange gift from an indifferent sky. 43 seconds is a short time. You could hold your breath for that long. You could walk across a street. In Hiroshima, in those 43 seconds, life continued in its ordinary, unexamined pace. A conversation was finished. A child took a bite of breakfast. A streetcar conductor checked his watch. 43 seconds of peace. The last 43 seconds of the old world. The bomb was not designed to hit the ground. Its altimeter was set to trigger the explosion at an altitude of 1,900 feet. The optimal height to maximize the destructive power of the blast wave against the city's fragile structures. As little boy reached that predetermined point in the air, a barometric switch closed. An electrical signal fired the cordite charge. The uranium bullet, traveling at 1,000 feet per second, shot down the gun barrel inside the bomb's casing and slammed into the uranium target. In less than a millionth of a second, a runaway nuclear chain reaction began. Uranium atoms split, releasing neutrons, which split more atoms, which released more neutrons. A cascade of fission, doubling and redoubling in a furious, unstoppable storm of energy. The first thing that happened was not a sound. It was not a shock wave. It was light, a silent, searing, impossible light. Imagine the sun. Now imagine a second sun, appearing in an instant, less than 2,000 feet, above the heads of 250,000 people. A sun that was not 93 million miles away, but right there, in the sky above your city, a man-made star, reaching a temperature of millions of degrees at its core. They called it the Pica asterisk. The flash. It was a light that bleached the world of all color, replacing it with a single, uniform, blinding white. It was brighter than anything anyone had ever seen. It was a light that carried with it an incredible, unimaginable heat, a thermal pulse that swept across the city at the speed of light. In the first second, the surface temperature on the ground, directly beneath the explosion, the hypocenter, reached an estimated 7,000 degrees Fahrenheit. Hotter than the melting point of steel. Roof tiles bubbled and melted. Granite steps were permanently etched with the shadows of people who were sitting on them. Those people ceased to exist in an instant. They were not burned. They were vaporized. Their bodies turned into a puff of carbon and steam, leaving only a dark stain on the stone where they had been. Further out, the effects were just as horrific. The thermal pulse was so intense that it burned dark-colored patterns of clothing directly onto people's skin. A woman wearing a kimono with a dark flower pattern would have the flowers seared into her flesh. Dark clothing absorbed the heat, while light clothing reflected it, creating a grotesque, permanent photograph of their final moments. Exposed skin was flash-burned. People felt a sudden, intense heat, as if they had been pushed into a furnace. Many who were indoors, looking out a window, had their faces burned, their eyeballs melted. The light itself was a weapon. Miles away, aboard the Enola Gay, the crew saw it. Even with their welding goggles on, the cockpit was filled with a brilliant purple-white light. My God, the co-pilot, Captain Robert Lewis, scribbled in his log. He was trying to document the moment, but the words felt small, inadequate. Then came the sound. The dawn asterisk. The light travels faster than sound, so for a few seconds, the destruction happened in an eerie, profound silence. The city was being incinerated without a whisper. But the explosion had also created a shockwave, a wall of compressed air moving outwards at supersonic speeds. When it hit the Enola Gay, already miles away, it felt like being struck by a telephone pole. The plane was violently shaken twice. The tail gunner, Bob Karen, shouted over the intercom that he could see the wave coming. He described it as a shimmering distortion in the air, like the heat rising from a hot pavement, but rushing towards them. The crew thought they were taking anti-aircraft fire. They couldn't comprehend that it was the echo of their own weapon, still powerful enough to rattle a 10-ton bomber from 11 miles away. On the ground, the dawn asterisk was not a sound. It was a physical force, an invisible, crushing hammer. The overpressure at the hypocenter was immense, estimated at over 6,000 pounds per square foot. No structure built by man could withstand it. Concrete and steel buildings were gutted, their interiors scoured clean, their windows blown out. But Hiroshima was a city of wood. 70,000 of its 76,000 buildings were made of wood and paper. They didn't stand a chance. They were not blown over. They were crushed. They imploded, shattering into millions of pieces of splintered timber and debris. One moment, a house stood there. The next, a pile of kindling. The blast wave moved with a deafening roar, a physical presence that ripped and tore and annihilated everything in its path. People were picked up and thrown like dolls. They were slammed into walls or buried under the wreckage of their own homes. Others were killed by the sheer pressure, their internal organs ruptured. Glass from shattered windows became a storm of tiny, lethal projectiles, flying faster than bullets, shredding anyone in their path. The world had been changed in an instant. The physics of the universe had been turned into a weapon of unimaginable power. Before we walk through the ruins and witness the human cost of that weapon, if these deep dives into history help you find quiet in a noisy world, consider subscribing to The Dark Historian. It allows these stories to continue being told. Now, we return to the City of Ash. After the initial flash and the blast wave, a third destroyer was unleashed. Fire. The thermal pulse had ignited thousands of small fires all across the city. The shattered wooden buildings provided an almost infinite supply of fuel. And then the blast wave, which had moved outwards, created a vacuum. Air from the surrounding areas rushed back in to fill it. This created a ferocious wind, fanning the small fires, merging them together. Within minutes, the entire city center was engulfed in a firestorm. It is a phenomenon so intense it creates its own weather system. The column of superheated air rises, drawing in more and more oxygen from the periphery, creating hurricane-force winds that blow inwards. Towards the center of the fire, the temperature inside this inferno reached over 1,000 degrees. Asphalt on the streets boiled, rivers evaporated. Anyone who had survived the initial blast but was trapped in the wreckage was incinerated. The sky, which had been so perfectly blue just minutes before, was now a churning vortex of black and gray smoke, lit from below by an orange-red glow. As the massive column of smoke and debris rose, it cooled in the upper atmosphere. The moisture condensed, mixing with the ash, soot, and radioactive particles from the bomb. And then it began to rain. But this was not a cleansing rain. It was a black, greasy, radioactive rain. It fell on the survivors, staining their skin, poisoning them from the outside. The thirsty, desperate people looked up and opened their mouths to catch the drops, not knowing they were drinking poison. This black rain would become a source of sickness and death for years to come. From the air, the crew of the Enola Gay looked back. What they saw was no longer a city. It was a boiling, churning cauldron of black smoke, pierced by angry red flames. A perfect mushroom cloud, beautiful and terrible, was climbing into the stratosphere, reaching 40,000 feet. It was a funeral pyre for 100,000 souls. What have we done? Robert Lewis wrote in his log. It was a question that would echo for the rest of his life. Down below in the ruins, the first survivors began to stir. They pushed aside wreckage, dazed and confused. Their world had been erased in a flash. They didn't understand what had happened. A single bomb. No, that was impossible. It must have been a massive raid, a new kind of incendiary. They were burned, bleeding, and horrifically injured. Their clothes had been ripped from their bodies by the blast. Their skin was hanging off in strips. They moved in a slow, silent procession, a parade of ghosts shuffling through a nightmare landscape. They were all heading in the same direction, towards the rivers, seeking relief from the consuming fire and their terrible burns. They held their arms out in front of them to keep the burned skin from touching their bodies. They made no sound. No one cried out. The shock was too great, the horror too absolute. They were simply a silent, stumbling mass of humanity, stripped of everything. This was the dawn of the atomic age. Not in a laboratory in New Mexico, but here, in the smoldering ruins of a city among the walking dead. The science had been proven. The weapon worked. But for the people on the ground, the ordeal was just beginning. For those who had survived the Pika and the dawn, a new, invisible killer was already at work inside their bodies. The gamma rays and neutrons released by the explosion had passed through them, damaging their cells, rewriting their future. They thought they had survived the worst. They were wrong. The quietest part of the bomb's power, the radiation, was just starting its slow, methodical work. The story of Hiroshima was not over. In many ways, it was just getting started. And for those in Washington, and for the generals on the island of Tinian, the silence from Tokyo was the most dangerous sound in the world. 3 days had passed since the city of Hiroshima had been erased from the map. 3 days of radio silence, of frantic intelligence gathering, of waiting. From the American perspective, the message sent by the atomic bomb should have been unmistakable. Unconditional surrender, or face utter annihilation. But the Japanese leadership was paralyzed, caught between disbelief and denial. How could a single bomb do such a thing? The reports were fantastical, impossible. Some military leaders argued it wasn't a bomb at all, but some kind of atmospheric trick, a chemical agent sprayed from the sky. Others believed it was real, but that the Americans could only have one. A scientific miracle, a singular achievement that could not be repeated. They would absorb the blow, rally the national spirit, and prepare for the invasion of the homeland. They would arm civilians with bamboo spears if they had to. Surrender was not an option. This thinking, this hope that Hiroshima was an anomaly, was precisely what the architects of the Manhattan Project had feared. It's why the plan had never been to drop just one bomb. One bomb is a spectacle. It is a tragedy. But two bombs is a production line. It is a statement of industrial capacity. It proves, without a shadow of a doubt, that you can do this again and again and again. It transforms a singular horror into a systematic threat. And so, the clock was ticking down on a second city. On Tinian, the ground crews worked under the immense Pacific heat, their movements practiced, deliberate, and grim. They were preparing the second weapon. This one was different. It was codenamed Fat Man. Unlike the sleek, gun-barrel design of the little boy that had leveled Hiroshima, this bomb was bulbous, almost cartoonish in its shape. It looked less like a weapon and more like a piece of experimental machinery. And in a way, it was. Its heart was not uranium, but a core of plutonium, a man-made element barely a few years old. The challenge of plutonium was that you couldn't just slam two pieces of it together like you could with uranium. It was too unstable. It would fizzle out before it could achieve a full-scale nuclear chain reaction. So, the scientists at Los Alamos had devised a solution of breathtaking complexity and violence. They would surround a grapefruit-sized sphere of plutonium with a perfectly symmetrical shell of high explosives. When detonated, this shell would crush the plutonium core inward, compressing it with unimaginable force until it reached critical mass. An implosion. It was a far more efficient and far more powerful design, but it was also much more difficult to build. It was, in essence, the future of nuclear weaponry. The target for this new device was the city of Kokura, a city on the northern coast of Kyushu, home to one of Japan's largest arsenals. It was a city of smokestacks, of factories churning out the last vestiges of Japan's war machine. The primary target. The secondary target, if weather or other problems arose, was Nagasaki, a port city nestled in a long, winding valley. On the morning of August 9, 1945, the B-29 bomber known as Boxcar lifted off from the runway on Tinian. Inside its bomb bay, Fat Man sat, armed and ready. The flight was tense from the start. A fuel pump malfunctioned, adding a new layer of anxiety. Fuel was now a critical, minute-by-minute calculation. When they reached the rendezvous point to meet their accompanying observation planes, one of them was a no-show. The minutes ticked by. 40 precious minutes wasted circling, burning fuel, waiting for a plane that would never arrive. Finally, the pilot, Major Charles Sweeney, made the call. They would proceed alone. They flew on toward Kokura, but as they approached, their hearts sank. The city was obscured. A thick blanket of haze and smoke, likely from a conventional bombing raid on a nearby city the day before, covered everything. They couldn't get a visual. The orders were clear. This was not a weapon to be dropped blindly. They had to see the target. For nearly an hour, Boxcar circled high above the clouds. 3 passes. 3 times they tried to find a break in the haze. Down below, the people of Kokura went about their morning, completely unaware that they were living on borrowed time, that the only thing standing between their city and total oblivion was a layer of smoke. You can imagine the frustration in that cockpit. The dwindling fuel gauge, the weight of the weapon in the belly of the plane, the pressure of the mission. Finally, with fuel critically low, the decision was made. They had to abandon Kokura. They would try for the secondary target, Nagasaki. Nagasaki was a city with a different soul. It was one of Japan's oldest and most international ports, the first gateway to the West centuries ago. It was a city of hills and valleys, its homes and businesses clinging to the steep slopes that rose from the Urakami River. It was also home to the largest Christian population in Japan, a legacy of Portuguese missionaries from the 16th century. Its geography, its very landscape, would play a crucial role in what was about to happen. As Boxcar limped toward Nagasaki, the weather there was no better. A thick deck of clouds covered the city. It seemed the mission might be a total failure. They would have to ditch the multi-million-dollar bomb in the ocean and try to make it back to Okinawa on fumes. But just as they were about to give up, the bombardier, Captain Kermit Behun, saw it. A hole, a brief, fleeting gap in the clouds. It wasn't over the planned aiming point in the city center, but it was over the industrial Urakami Valley, home to the Mitsubishi Steel and Arms Works. It was enough. "I've got it," he said over the intercom. The bomb bay doors opened. At 11:02 a.m. local time, Fat Man was released. It fell for 47 seconds. The people below who happened to look up saw a glint of metal, a small object tumbling through the sky. A few seconds later, the world was replaced by light, a light not of this earth. It was a silent, searing flash of pure, unfiltered energy. It was followed by a wave of heat so intense it vaporized people where they stood, leaving only their shadows burned onto stone walls. Then came the sound, a deafening, world-shattering roar that was felt as much as it was heard. The blast wave, channeled by the steep hills of the Urakami Valley, acted like a shotgun blast, focusing the destruction with unimaginable fury. Buildings were not just knocked down, they were pulverized, turned into a storm of splintered wood and shrapnel that scoured the valley clean. The Mitsubishi factories, the primary military target, were utterly annihilated, but so was everything else in the valley. The Nagasaki Medical College and Hospital, one of the most advanced in Asia, was obliterated. Hundreds of doctors, nurses, and patients were killed instantly. Churches, temples, and schools disintegrated. The silence that followed the roar was a silence of profound shock, a moment of quiet horror that stretched for miles. And as we sit with that silence for a moment, if you find value in these explorations of history's darkest hours, a subscription to The Dark Historian helps ensure these stories continue to be told. It is a small gesture that means a great deal. Now, let us return to the Urakami Valley, where the survivors were just beginning to understand what had happened to their world. For those who survived the initial flash and blast, a new hell was just beginning. The city was on fire. A massive firestorm began to brew, sucking the oxygen out of the air and turning the sky a terrifying, dark orange. A strange, greasy black rain began to fall. It was made of soot, dust, and highly radioactive particles sucked up into the mushroom cloud and now falling back to Earth. It stained the skin and contaminated the very water the survivors were so desperate to drink. Sumitru Taniguchi was a 16-year-old boy delivering mail. He was over a mile from the hypocenter when the bomb detonated. The heat blast hit his back, melting the skin and flesh from his bones. He was thrown from his bicycle and lay on the ground, conscious but unable to move, for 3 days. When he was finally found, his back was a raw, red, unrecognizable mass of tissue. He would spend years in a hospital, lying on his stomach, enduring unimaginable pain as his body slowly, miraculously, tried to heal itself. His story, and the horrific photographs of his injuries, would become a lasting testament to the unique cruelty of these weapons. Because of Nagasaki's hills, the destruction was geographically contained in a way Hiroshima's was not. The main part of the city, over the hills from the Urakami Valley, was largely shielded from the initial blast. People there saw the flash and heard the roar, but their homes remained standing. When they rushed to see what had happened, they climbed the hills and looked down into the valley. What they saw was incomprehensible. An entire section of their city had simply ceased to exist, replaced by a smoking, flattened ruin. The immediate death toll was staggering, estimated at around 40,000. But like in Hiroshima, that was only the beginning. In the days, weeks, and months that followed, tens of thousands more would die from horrific burns, from injuries sustained in collapsing buildings, and from the invisible killer radiation sickness. This was a new kind of death. People who seemed to have survived unscathed would suddenly develop fevers. Their hair would fall out, purple spots would appear on their skin, and they would die in agony as their bodies broke down from the inside. The doctors who survived had no name for this illness, no way to treat it. They could only watch, helpless, as their patients wasted away. Back in Tokyo, the news arrived. Another city, another special bomb. The argument that Hiroshima was a fluke, a one-off, was now utterly destroyed. The Americans didn't have one. They had at least 2, and they had used them just 3 days apart. The implication was terrifying. They had a production line. They could and would continue to do this every few days until Japan was nothing but a scorched wasteland. And as if that wasn't enough, another piece of devastating news arrived on that very same day. The Soviet Union, which had remained neutral in the Pacific War, had just declared war on Japan. A massive Soviet army was pouring across the border into Manchuria, crushing the depleted Japanese forces there. The final hope of a negotiated peace, with the Soviets acting as mediators, was gone. Japan was now trapped, attacked by a new superpower from the West, and facing systematic nuclear annihilation from the East. The Supreme War Council met in a sweltering bunker deep beneath the ruins of Tokyo. The mood was desperate. Even now, the council was split. The military hardliners, men like War Minister Anami, argued for a final, glorious battle on the home islands. They spoke of national honor, of the samurai spirit. To them, surrender was a fate worse than death. They would rather see the entire nation of Japan perish than submit to the enemy. But others, led by the Foreign Minister Togo, argued that the time for such talk was over. The nation was not just being defeated, it was being erased. The people were suffering beyond comprehension. To continue the war was not honorable, it was suicide. The debate raged for hours, a bitter, emotional deadlock. They could not agree. The fate of millions hung in the balance, trapped by the indecision of a handful of men in a bunker. This is where the story of the Second World War takes a truly unprecedented turn. For centuries, the Emperor of Japan had been a divine figure, a god on earth who reigned but did not rule. He was expected to remain above the grubby business of politics, to simply approve the decisions made by his government. But Emperor Hirohito had been listening. He had heard the reports from Hiroshima and Nagasaki. He understood the new reality his generals refused to accept. In the early morning hours of August 10th, he summoned the council. They gathered before him, their faces grim. He listened to their deadlocked arguments one last time. Then he spoke. His voice was quiet, high-pitched, but it carried the weight of absolute authority. He said that he could no longer bear to see his innocent people suffer. He spoke of the enemy's new and cruel bomb, of the impossibility of continuing the fight. He said he had made his decision. Japan would accept the Allied terms for surrender. He would, he said, bear the unbearable. The room was stunned into silence. The emperor had spoken. He had broken with centuries of tradition to personally intervene and end the war. For the military hardliners, it was a devastating blow. A few would later commit ritual suicide rather than accept the dishonor of surrender, but for the nation of Japan and for the rest of the world, it was the end. The second strike, the bomb that fell on Nagasaki, had done what the first could not. It had broken the political paralysis. It had shattered the illusion that Japan could somehow survive this. The city of Kokura had been saved by a fluke of the weather, but the people of Nagasaki had paid the price. Their sacrifice, unwilling and horrific, had become the final terrible punctuation mark at the end of the most destructive war in human history. The bombs had fallen. The war was over. But the world had been changed forever. The twin mushroom clouds over Hiroshima and Nagasaki cast a long, dark shadow over the future of humanity. The fear they created, the questions they raised about science, power, and our own capacity for self-destruction would define the next half-century. A new age had dawned, the atomic age, and a new, far colder war was just beginning, and so the world held its breath. It was a new kind of silence that fell over the planet. Not the quiet of peace, not yet. It was the silence of anticipation, the silence of a question hanging in the air, a question written in mushroom clouds and vaporized cities. In Tokyo, the silence was thickest. It filled the halls of the imperial palace, a heavy blanket of shock and disbelief. The Supreme Council for the direction of the war was paralyzed. They had seen the reports from Hiroshima. Unbelievable, a single bomb. Then the reports from Nagasaki. It was a pattern, a terrible, undeniable pattern. The enemy, it seemed, could now erase their cities from the map, one by one, with a speed and finality that defied all military logic. For days, they argued. The militarists, the hardliners, still spoke of a glorious death, of arming civilians with bamboo spears to meet the invaders on the beaches. They spoke of honor. They spoke of a fight to the last man, woman, and child. But their voices, for the first time, sounded hollow, brittle. How do you fight an enemy who can command the sun to fall from the sky? What honor is there in a nation of ghosts? And then there was the other silence, the one that came from Moscow. The Soviet Union, that sleeping giant to the north, had declared war. Their armies were now pouring into Manchuria, crushing what was left of Japan's once mighty Kwantung army. The strategic situation was no longer dire. It was impossible. Caught between two titans, one with an atom bomb, the other with an endless sea of men. There was no path to victory. There was no path to anything but annihilation. The decision fell, as it always does in the end, to one man, Emperor Hirohito, a figure considered by his people to be a living god, a descendant of the sun goddess herself. But in that sweltering August of 1945, in a bunker beneath his palace, he was just a man staring into the abyss. He listened to his generals and his ministers, their faces slick with sweat, their arguments circular and desperate. He heard their talk of honor and sacrifice, and he made a choice. He chose to bear the unbearable. Imagine that room, the air thick with cigar smoke and the smell of fear. Imagine the moment he spoke, his voice quiet but firm, announcing that the war must end, that the suffering of his people must end. It was a moment that shattered 1,000 years of tradition. A god choosing surrender, but the decision was one thing, announcing it was another. The people of Japan had never heard their emperor's voice. He was a symbol, a photograph, a presence. To speak to them directly on the radio was unprecedented. It was unthinkable. A recording was made. The emperor, reading his imperial rescript on the termination of the war, his voice formal, high-pitched, and filled with a carefully controlled sorrow. The vinyl disc containing his words became the most precious and the most dangerous object in the entire empire, because the war was not quite over. A faction of young, fanatical army officers refused to accept the news. They believed the emperor had been betrayed by weak-willed politicians. They believed surrender was the ultimate dishonor. And so, on the night of August 14th, they launched a coup. They stormed the imperial palace, searching for that one single recording. Their plan was simple: find it, destroy it, and continue the war. The palace grounds became a scene of chaos. Guards were killed. Fires were set. The rebels, led by a man named Major Kenji Hatanaka, were desperate. They searched the imperial household ministry, tearing rooms apart, their boots echoing in the silent, ornate halls. But the recording was not there. The imperial chamberlain, a loyal servant, had foreseen this. He had hidden the records. He smuggled them out of the office in a laundry basket, concealing them in a small bunker used by the Empress's staff. For hours, the rebels hunted. The fate of millions, the very future of Japan, rested on whether they could find a small, black disc of vinyl. They never did. As the sun rose on August 15th, the coup collapsed. The leaders, realizing their failure, took their own lives. And at noon, the people of Japan gathered around their radios. They stood in stunned silence as the unfamiliar, reedy voice of their emperor filled the airwaves. He spoke in a formal, archaic Japanese that many struggled to understand. He never used the word surrender. He spoke of the war situation developing not necessarily to Japan's advantage. He spoke of a new and most cruel bomb. But the meaning, however veiled, was clear. The war was over. For most of the world, the news came in waves. First, the rumors. Then, the official announcements crackling over the radio. In Times Square, in Piccadilly Circus, in cities and towns across the Allied nations, a wave of pure, unadulterated joy erupted. Strangers kissed. People danced in the streets. It was VG Day. Victory over Japan. The final, brutal chapter of the Second World War was closed. For the soldiers and sailors still in the Pacific, it was a different kind of relief. It was the sudden, breathtaking realization that they were going to live, that they wouldn't have to storm those beaches, that the next sunrise wasn't a threat. It was a promise, the promise of home. But underneath the celebration, a new feeling was beginning to stir. A sense of awe, mixed with a deep and profound unease. The newspapers were filled with stories about the atomic bomb. They printed diagrams. They tried to explain the science, talking of splitting atoms and chain reactions. But the words were inadequate. The numbers were too large to comprehend. A bomb with the power of 20,000 tons of TNT, a light brighter than 1,000 suns. People looked at the first photographs from Hiroshima. The blurry, grainy images of a city that was simply gone. A flat, gray wasteland where a vibrant community had once stood. They saw the ghostly shadows of people baked onto stone walls. It didn't look like the aftermath of a conventional bombing. It looked like something from another world, something biblical. And you have to remember, this was a world that was just beginning to understand the full horror of what humanity was capable of. The gates of the Nazi concentration camps had been thrown open only months before. The world had seen the pictures from Auschwitz and Dachau. It had recoiled in horror. There was a sense that humanity had looked into the abyss and now, perhaps, was stepping back. But this was different. This wasn't about ideology or hatred or industrial-scale murder. This was about power. A new kind of power. The power to unmake the world. The power to create a star on Earth. It was a terrifying, Promethean leap. And no one knew what it meant. The world celebrated an ending, the end of a long and terrible war. But the men who had created that ending could not join in. Their war, a private war within their own minds, was just beginning. Before we explore that silent conflict, the one that raged in the hearts of the scientists at Los Alamos, if you are finding these stories help you rest, consider subscribing to The Dark Historian. It allows us to continue unearthing these forgotten histories. Now, back to the silent desert, and the men who were beginning to understand what they had truly done. For the scientists of the Manhattan Project, the news of the surrender brought a complex and often contradictory flood of emotions. There was, of course, relief. Their work had, in their view, ended the war. It had saved the lives of hundreds of thousands of American soldiers who would have died in an invasion. At Los Alamos, the remote mesa where they had lived and worked in secret for years, there were parties. People drank and cheered. The pressure, the immense, crushing pressure of the last 3 years, was finally gone. But for many, the celebration felt wrong. It felt hollow. Robert Wilson, a physicist who headed the cyclotron group, remembered the scene. He saw his colleagues, brilliant men and women he respected, getting drunk and celebrating, and he felt a profound sense of disgust. What we have done is a terrible thing, he thought. He walked away from the party, into the quiet of the New Mexico night, and was simply sick. This feeling, this moral hangover, began to spread through the community like a quiet contagion. They had been so focused on the problem, on the physics, on the engineering. They were in a race against the Nazis, a race they believed was for the survival of the free world. They had solved the puzzle. They had built the machine. And now, in the quiet aftermath, they were forced to look at what the machine had done. They read the first detailed accounts from Hiroshima. John Hersey's landmark report, which documented the experiences of 6 survivors, was a thunderclap. It described the keloid scars, the radiation sickness, the black rain. It gave a human face to the abstract physics. It transformed the target back into a city full of people, and for many scientists, it was unbearable. J. Robert Oppenheimer, the brilliant, enigmatic director of the project, became the public face of this scientific anguish. He was a hero to the public, the father of the atomic bomb. But privately, he was haunted. He met with President Truman and famously told him, "Mr. President, I feel I have blood on my hands." Truman, ever the pragmatist, was dismissive. He later told an aide, "I told him the blood was on my hands, to let me worry about that." But Oppenheimer couldn't let it go. He saw the future. He saw an arms race, with nation after nation building bigger and more powerful weapons. He saw a world living in perpetual fear, a world where a single political miscalculation could lead to global annihilation. His famous recitation of the line from the Bhagavad Gita, "Now I am become death, the destroyer of worlds," was not a boast. It was a lament, a confession. He wasn't alone. Leo Szilard, the Hungarian physicist who had first conceived of the nuclear chain reaction and had written the letter with Einstein that spurred Roosevelt to start the project, was horrified. His great fear had been that Nazi Germany would build the bomb first. Once Germany was defeated, he saw no justification for using the weapon, especially against a civilian population. He had circulated a petition among the Chicago scientists, begging the president not to use the bomb without a demonstration and a warning. It had been ignored, buried in the bureaucracy of the war machine. Now, Schiller dedicated the rest of his life to undoing what he had helped start. He became a tireless advocate for civilian and international control of atomic energy. He argued that the secret of the bomb could not be kept forever. Other nations would figure it out. The only way to prevent a nuclear arms race, he believed, was to create a system of global governance to put this terrible power under the control of a world authority. It was a radical idea, and in the climate of emerging Cold War paranoia, it was a doomed one. These scientists, men who had been celebrated as patriotic heroes, were now viewed with suspicion. They were accused of being naive, or worse, disloyal. Edward Teller, one of the key physicists on the project and a fierce advocate for building an even more powerful weapon, the hydrogen bomb, turned against Oppenheimer. He testified against his former boss in a security hearing, effectively destroying Oppenheimer's career and his access to the government he had served. The scientific community was torn apart. It was a conflict between those who believed the only answer to the bomb was a bigger bomb, a stronger deterrent, and those who believed the only answer was to put the genie back in the bottle, or at least, to build a stronger bottle to contain it. In 1947, a group of these concerned scientists, many from the Manhattan Project, created a journal, the Bulletin of the Atomic Scientists, and on the cover of their first issue, they placed a simple, stark image, a clock. Its face was a quarter of a circle, the final 15 minutes. The hands were set at 7 minutes to midnight. Midnight represented nuclear annihilation. The doomsday clock, as it became known, was not a prediction. It was a warning. It was a metaphor for humanity's proximity to self-destruction. The scientists who created it were trying to shout from the rooftops. They were trying to tell the world that the game had changed, that the old rules of war and diplomacy no longer applied. Think of that image, a simple clock, designed by an artist named Martile Langsdorff, the wife of one of the physicists. It was a quiet, chilling, and profoundly powerful symbol of the new age, the atomic age. It wasn't an age of promise and limitless energy, as some had naively hoped. It was an age of anxiety, an age defined by a clock face, its hands hovering ever closer to the final second. The silence that had followed the bombs was now filled with a new sound, a quiet, rhythmic, and relentless ticking. The sound of a world that now knew, with absolute certainty, how it all could end. It was the sound of a new kind of fear, a fear that settled deep into the bones of civilization, a permanent resident in the back of everyone's mind. The war was over. The celebrations had faded, and the world was left to sit in the long, cold shadow of what it had built, listening to the clock, wondering, with every tick, if this was the moment the hand would finally move, wondering if the great, blinding light would come again, not as an act of war this time, but as the final, terrible act of humanity itself. And so, the world held its breath. It was a strange new silence that fell over the globe in the years after 1945, not the silence of peace, but the hush of a library where someone has just dropped a glass, and everyone is waiting to see if it will shatter. The genie was not just out of the bottle. It had burned the bottle to glass, and now it cast a shadow over everything. The question was no longer if another nation could build the bomb. The question was simply when. For 4 years, the United States existed in a state of unparalleled and terrifying solitude. It held in its hands the power to end civilization, a power it had used twice, and a power that now defined its place in the world. Every diplomatic conversation, every political maneuver was underpinned by this unspoken threat. The atom was an American monopoly, but monopolies, by their very nature, invite competition, and the competition was already well underway in secret cities scattered across the vastness of the Soviet Union. You see, the knowledge could not be contained. The physics that unlocked the atom in the deserts of New Mexico were the same physics that existed in the minds of scientists in Moscow, in London, in Paris. The secret was not that it could be done. The secret was how, and secrets, especially of this magnitude, have a way of spreading. Espionage played its part, of course. Men and women, driven by ideology, passed papers and formulas across borders, convinced they were balancing the scales of a world tilted dangerously in one direction. But even without them, it was inevitable. A matter of time, resources, and will. And the Soviet Union had the will. The morning of August 29th, 1949, began like any other. In the United States, people went to work. Children went to school. The post-war boom was in full swing. But thousands of miles away, in the empty plains of Kazakhstan, a tower stood, cradling a device codenamed First Lightning. It was a near-perfect copy of the Fat Man bomb that had destroyed Nagasaki. At 7 a.m, it was detonated. The world did not find out immediately. But in the upper atmosphere, American weather reconnaissance planes, specifically designed for this one purpose, sniffed the air. They flew their lonely, prescribed routes, collecting samples day after day, and a few days after the test, a plane scooped up what the scientists had been dreading: telltale radioactive isotopes, the signature of nuclear fission, the fingerprints of a bomb. The evidence was undeniable. It was analyzed and reanalyzed. The shock in Washington was seismic. The monopoly was over. The solitary god was no longer solitary. There were now two nations on opposite sides of a new ideological chasm, both armed with the fire of the stars. The Cold War, a conflict of shadows and whispers, had just become something infinitely more dangerous. It had become a nuclear standoff. The age of anxiety had truly begun. The response in America was not one of quiet contemplation. It was one of fear, a deep, primal fear that now the fire could be returned. The bomber planes that had flown with impunity over Japan could now, in theory, be met with their own kind. The comfortable distance of oceans no longer felt like a shield. It felt like a delay, at best. This fear gave rise to a question born in the minds of men like Edward Teller, a physicist who had worked at Los Alamos and had always been more interested in the next step. If fission, the splitting of the atom, could create such a destructive force, what about fusion, the very process that powers the sun, not splitting atoms apart but forcing them together? The idea had been theorized for years, a distant, monstrous possibility. They called it the super. The debate was fierce. Robert Oppenheimer, the man who had willed the first bomb into existence, was now haunted by it. He argued passionately against the development of this new weapon. He saw where this road led, a constant, upward spiral of destructive power with no logical end. He argued that the atomic bomb was powerful enough. To build a weapon 1,000 times more powerful was not a military necessity. It was, he believed, an act of genocide. He pleaded for international control, for restraint, for a step back from the abyss. But fear is a more powerful motivator than restraint. The logic of the Cold War was simple and brutal. If we could build it, they could build it, and it was better to be the first. The argument that won the day was not one of morals, but of survival. The president, Harry Truman, made the decision. The United States would pursue the hydrogen bomb. It was no longer a question of if, but how fast. This wasn't just an engineering project. It was a crusade, fueled by paranoia and a seemingly bottomless budget. The scientific and technical challenges were immense, far greater than those faced at Los Alamos, but they were overcome. To understand the leap in power, you have to try to visualize the unimaginable. The bomb that destroyed Hiroshima was measured in kilotons, thousands of tons of TNT, The new weapon, the hydrogen bomb, would be measured in megatons, millions of tons of TNT. Think of it this way. The Hiroshima bomb destroyed a city. The hydrogen bomb could erase a metropolis, the 5 boroughs of New York City, the entirety of London. Gone. Not just flattened, but vaporized. The fireball alone would be miles wide. The effects would not just be local. The radioactive fallout could poison continents, carried on the winds, silently falling on cities and towns thousands of miles away. This was a different kind of weapon. It wasn't a weapon of war anymore. It was a weapon of planetary extinction. And as the United States raced to build their super, the Soviets were doing the exact same thing. The race was on. Before we explore the strange, terrifying peace this new power created, a peace built on the promise of annihilation, take a moment. If you find these stories, these journeys into the darker chapters of our past, help you to rest or to think, consider subscribing to The Dark Historian. It allows these stories to continue being told. Now, back to the precipice. The first test of a true hydrogen device took place on November 1st, 1952. On the tiny, idyllic island of Alujilab in the Enewetak Atoll in the Pacific Ocean. The device was codenamed Ivy Mike. It wasn't a bomb in the traditional sense. It was a colossal, multi-story building, a cryogenic factory filled with liquid deuterium, weighing over 80 tons. A science experiment on a terrifying scale. When it was detonated, it yielded a force of 10.4 megatons, almost 1,000 times more powerful than the Hiroshima bomb. The fireball was nearly 4 miles wide. The mushroom cloud rose 25 miles into the sky, eventually spreading out 100 miles across. And the island of Alujilab, it was gone, simply gone. Where a piece of land had once existed, there was now a crater, over a mile wide and deep enough to hold a skyscraper. The water that rushed back in was a boiling, radioactive soup. The scientists watching from a safe distance, 30 miles away, felt the heat on their faces, a profound, unnatural heat. They had not just unleashed the power of the sun. They had, for a moment, created a small, man-made star on the surface of the earth. The secret did not last long. Less than a year later, in August 1953, the Soviet Union tested their own thermonuclear device. It was smaller, less powerful, but it was deliverable by an airplane. It was a true hydrogen bomb. The race was over. Both sides had reached the finish line. Both sides now held the power to destroy the other, and the rest of the world completely. This new reality needed a new name, a new doctrine to explain how two superpowers could possess such apocalyptic power and not use it. It came to be known by a simple, chilling acronym. MAD, mutually assured destruction. The logic was as simple as it was insane. If both sides knew that a first strike would be met with an overwhelming, civilization-ending second strike, then neither side would dare to attack. The only way to win was not to play. Peace, a fragile, terrified peace, would be maintained by holding a gun to each other's heads, with fingers trembling on the triggers. It was the sanity of madness, a balance of terror, and so, the arms race accelerated into a new, frantic phase. It was no longer just about building bigger bombs. It was about building more of them, and building better ways to deliver them. The B-52 bomber, a giant metal bird that could fly across the globe and drop a payload of hydrogen bombs, became the symbol of American power. The Soviets developed their own. Then came the missiles. Intercontinental ballistic missiles, ICBM. They could travel from a silo in Siberia to a city in the American Midwest in 30 minutes. There was no defense, no way to stop them. They were the ultimate 30-minute apocalypse. So both sides built thousands of them, burying them in hardened concrete silos, pointing them at each other, ready to launch at a moment's notice. And then they put them on submarines. Nuclear-powered submarines that could hide in the depths of the ocean for months at a time, their locations unknown. Each one carried enough firepower to destroy dozens of cities. This was the nuclear triad: bombers, land-based missiles, and submarine-based missiles. It was a system designed to guarantee that even if a surprise attack wiped out a nation's leadership and its land-based weapons, there would always be a response. The submarines, the silent hunters, would rise from the depths and unleash their vengeance. This is what assured destruction meant. It meant total. It meant absolute. It meant there was no hiding place. This terror seeped into the very fabric of daily life. You could feel it. The world was divided into two camps, and the line between them was a nuclear tripwire. In schools, children practiced duck and cover drills, an absurd ritual where they were taught to hide under their wooden desks, as if that could offer any protection from a thermonuclear blast. But it was a ritual of control, an attempt to do something in the face of an unthinkable, uncontrollable power. People built fallout shelters in their backyards, little concrete tombs stocked with canned goods and water, hoping they could ride out the end of the world. Popular culture became saturated with the theme. Movies depicted nuclear holocaust. Books imagined the post-apocalyptic world. The mushroom cloud became the most recognizable and feared symbol of the 20th century. It was a strange way to live, under a constant, low-grade, existential threat. The knowledge that at any given moment, men in bunkers deep underground were waiting for an order that would be authenticated, confirmed, and executed in minutes. An order that would unleash a storm of fire and radiation upon the world. Every international crisis, every political tension, carried with it this new, terrifying weight. The Berlin crisis, the Cuban Missile Crisis, moments when the world held its breath, when the clock ticked perilously close to midnight, when the logic of man was tested to its absolute limit. The men in the silos, the pilots in the bombers, the submariners deep beneath the waves, they lived with this reality every day. They were trained for a mission they prayed would never come. They were the gatekeepers of the apocalypse, entrusted with the keys to the end of the world. Imagine the psychological burden. To know that your job, the one you have practiced for thousands of hours, is to end millions of lives. The world had built a cage for itself. A cage made of missiles, silos, and bomber fleets, and invisible submarines. And the bars of the cage were made of fear. The fear of mutual annihilation was the only thing keeping the peace. It was a system that had to work perfectly, every single time. A single mistake, a single miscalculation, a single false alarm that was believed and everything would be over. The silence that began after 1945 had deepened. It was no longer the hush of a room where a glass might shatter. It was the absolute, dead silence of a bomb disposal expert trying to decide which wire to cut, knowing that the wrong choice would mean oblivion. This was the legacy of the bomb. It did not bring the promised peace of a world war ended. Instead, it created a new kind of war. A Cold War, fought in the shadows, where the real battle was a technological and psychological race to maintain a balance of terror. The great, blinding light had been seen twice, and now, humanity had engineered thousands of them, each one vastly more powerful, and aimed them at itself. The world was left to wonder, to wait, in the long, quiet shadow of its own creation, waiting for a signal, a siren, a flash on the horizon, waiting for the end. Or perhaps, just learning to live with the impossible, paradoxical peace that its most terrible invention had created. A peace that always felt just one heartbeat away from the end of everything. And so we were left there, in that quiet, fragile space, a world held together by the promise of its own annihilation. A peace built not on trust, but on a shared, silent understanding of mutual destruction. It's a strange foundation for a civilization, isn't it? To know that the only thing keeping the world from ending is the certainty that it would end for everyone. This wasn't an idea that stayed in the halls of power, in the briefing rooms of generals and presidents. It seeped out, under the doors and through the cracks, becoming a part of the air everyone breathed. It was the low, persistent hum beneath the music of the decades that followed. You could feel it in the way people looked at the sky. A clear blue day was beautiful, of course, but there was always a new, quiet question hiding behind the clouds. Could this be the day? Children learned a new kind of game. Not tag, not hide and seek, but duck and cover. A drill where you would hide beneath a small wooden desk, hands clasped behind your neck, as if a few inches of plywood could hold back the fury of a sun brought down to earth. It was, of course, a ritual of absurdity, a prayer in the face of the inevitable. But it taught a generation a fundamental truth about their new world. The danger was no longer a soldier on a distant battlefield. The danger was everywhere and nowhere. It was a flash of light that could come at any moment. People built shelters in their backyards, concrete boxes buried in the earth, stocked with canned goods and bottled water, little tombs for the living, meant to wait out the death of the world above. Imagine the quiet desperation of that, sealing your family into the dark, listening to the silence, and wondering if you were the only ones left, wondering what kind of world you might find when the canned food ran out and you had to, finally, turn the handle on that heavy steel door. This constant, low-grade fear changed us. It shaped our stories, our movies, our art. The monsters were no longer creatures from swamps or distant planets. They were us. The greatest threat to humanity was humanity itself. We had seen our own capacity for destruction, and we could never unsee it. But humanity is a strange and resilient thing. We don't simply surrender to fear. We try to manage it. We try to build cages for the monsters we create. And so, the age of the bomb gave rise to the age of the treaty, an era of men in quiet rooms talking to stop the talking from ending forever. You have to picture the scene. Two superpowers, the United States and the Soviet Union, locked in a dance of ideology and ambition, each with thousands of nuclear warheads pointed at the other. Enough to destroy the world many times over. The overkill was a concept so insane, it was almost numbingly abstract. And yet, beneath the threats and the posturing, there was a shared terror. The leaders on both sides, for all their differences, were still human. They understood the finality of the weapons they controlled. So they began to talk. The conversations were slow, filled with suspicion. The Limited Test Ban Treaty of 1963 was a first, trembling step. It pushed the tests underground, out of sight, out of the atmosphere. It was an admission that the radioactive fallout, the strontium-90 settling into the bones of children, was a price too high to pay, even for a Cold War. The mushroom clouds that had become a symbol of terrible power vanished from the skies and the seas, retreating into the deep, secret places of the earth. But they were still there. The testing continued, just hidden from view, a problem buried, not solved. Then came the centerpiece of it all, the Treaty on the Non-Proliferation of Nuclear Weapons, the NPT. It was a grand, desperate bargain, a deal offered to the world. The nations that already had the bomb promised, vaguely, to work towards getting rid of theirs. In exchange, the nations that didn't have it promised not to try and build it. A global agreement to stop the bleeding. It was an imperfect shield. Some nations never signed. Others signed and then cheated. The knowledge, after all, was already out there. The science couldn't be put back into a box. But for a time it held. The nuclear club, the most exclusive and terrifying club on Earth, remained small. It was a testament to our collective will to survive. A fragile consensus that this particular fire was too dangerous for anyone else to play with. Even as they tried to contain the spread of the weapon, a different idea was taking hold. A beautiful, seductive idea. What if this incredible power, the power locked inside the atom, could be used for good? What if the same reaction that could level a city could instead be used to light it? This was the promise of atoms for peace. A new narrative. The atom was not a demon, but a genie that could grant infinite wishes. Clean, limitless energy. A world without pollution, without reliance on the finite resources buried in the ground. Nuclear power plants began to rise, their strange, curved cooling towers becoming new landmarks on the horizon. They were monuments to our own cleverness. We had tamed the beast. We had harnessed the power of the stars and put it to work boiling water. For a while, the dream seemed real. Nuclear reactors powered submarines that could travel the globe without surfacing. They powered distant research stations in the ice of Antarctica. They generated electricity for millions. The atom was becoming a quiet, reliable servant, but the shadow of the weapon never truly left. The same technology that could enrich uranium for a power plant could, with a few different steps, enrich it for a bomb. The line between creation and destruction was terrifyingly thin. Every nation with a peaceful nuclear program was a nation with a potential nuclear arsenal. The genie was never truly tamed. It was just on a leash, and sometimes the leash would break. The names are now etched into our collective memory. 3 Mile Island, Chernobyl, Fukushima, each one a story of human error, of mechanical failure, of nature's indifference to our plans. Each one a reminder that the power we were playing with was fundamentally unforgiving. Chernobyl was the ghost story that turned out to be real. A test gone wrong in the middle of the night. An explosion that tore the roof from the reactor building and set the graphite core on fire. A radioactive plume that drifted silently across Europe, carrying an invisible poison. It created an exclusion zone, a dead land where time has stopped. You can see the pictures. The abandoned schools, with books still open on the desks. The decaying amusement park, its Ferris wheel a skeleton against the sky. It's a modern Pompeii, but the volcano was one we built ourselves. A ghost city, haunted not by spirits, but by the lingering, patient decay of cesium and plutonium atoms. A wound on the earth that will take thousands of years to heal. These accidents revealed the other side of the nuclear promise. The cost of failure was catastrophic. The waste produced by these plants, a toxic legacy that would remain dangerous for longer than human civilization has existed, had to be stored somewhere. We created a poison with no antidote and no safe place to keep it. And so, the dream of clean, limitless energy became complicated, tarnished. The same fear that surrounded the bomb began to surround the power plants. It was the same fundamental problem. We had unlocked a power that operated on a geological timescale, but we were still just people. Fallible, short-sighted, and prone to mistakes. Before we explore the final echoes of this story, the human legacy left behind, I want to take a moment. If you are finding this journey into our darker history a source of calm or a way to quiet your mind, please consider subscribing to The Dark Historian. Your support is what allows these stories to be told. It helps ensure this space remains a quiet corner for reflection. Now, let us return to the heart of it all, to the people who started this fire. What of them? What of the scientists of the Manhattan Project? They lived the rest of their lives in the world they had helped create. They saw the arms race, the duck and cover drills, the fear in the eyes of the world. They had given humanity the ultimate tool of self-destruction, and now they had to live with that knowledge. J. Robert Oppenheimer, the father of the atomic bomb, became a kind of tragic prophet. After the war, he fought passionately for international control of nuclear energy. He argued for transparency, for a world where this power was shared and managed by all, to prevent a secret and terrifying arms race. He was a man who had looked into the abyss and was now desperately trying to warn everyone else not to fall in. But the world was not ready for that kind of trust. The Cold War had its own logic, its own momentum. Oppenheimer's pleas for caution were seen as weakness, even disloyalty. He was stripped of his security clearance, publicly humiliated, and pushed to the margins. The creator was cast out, his warnings ignored. He spent his later years in a quiet, contemplative exile, a man haunted by his own brilliant mind. He never shook the feeling that he had, as he famously said, become death, the destroyer of worlds. That weight was his constant companion. Others wrestled with it in different ways. Some, like Edward Teller, pushed for even more powerful weapons, believing that the only path to peace was through unquestionable strength. They saw the bomb not as a curse, but as a grim necessity, a guardian of the peace. And many of the rank-and-file scientists, the engineers, the technicians, simply went back to their lives. They became professors or worked in industry. They raised families in the very world they had made so precarious. How do you reconcile that? How do you sit down to dinner with your children, knowing that you helped build a weapon that could erase all the dinners, all the families, all the children from the face of the earth? Perhaps you compartmentalize. You tell yourself you were just a small part of a very large machine. You were just solving a problem. You were a patriot doing your duty in a time of war. And all of those things were true. But the larger truth, the one that must have surfaced in the quiet hours of the night, was that they had changed the very definition of what it meant to be human. Humanity had always been capable of great cruelty, of war, of genocide, but it had always been on a human scale. It took effort, it took armies, it took time. What they had created was different. It was destruction at the speed of light, impersonal, absolute, the power to end history itself, delivered in a single, blinding flash. This is the ultimate legacy of the bomb. It isn't the craters it left in the desert, or the ghost cities it created. It's the knowledge, the permanent and irreversible understanding of how to crack open the atom and release its terrible energy. That knowledge can never be forgotten. It will be with us for as long as we exist. We live in a different world now. The Cold War is over. The immediate, daily threat of nuclear war has receded for many. It no longer hums beneath the surface of everyday life. But the weapons are still here. Thousands of them, sitting silently in silos, in submarines gliding through the deep ocean, and in the bomb bays of aircraft. They are sleeping dragons. And we live in the hope that no one will ever be foolish enough to wake them. The story of the atomic bomb is a story of our own contradictions. It is a story of our brilliance and our folly, our capacity for incredible intellectual achievement, and our capacity for unimaginable destruction. It is the story of how a species that had only just learned to fly, that had only just begun to understand the universe, reached for the power of the gods and found itself holding a fire that could consume everything. The world was changed forever on that day in the New Mexico desert. A line was crossed, and we are still living in the long, quiet aftermath of that moment. We are all children of the atomic age. We were born into a world where our own extinction is a technical possibility, and so we are left with a profound and unending responsibility, a responsibility to remember, to understand, to be vigilant, a responsibility to choose creation over destruction, to choose wisdom over cleverness, to manage this terrible power with a humility it did not have at its birth. As you rest now, As the world outside goes on, think of that strange, quiet light that first bloomed in the desert. A light that promised a new kind of power, a new kind of war, a new kind of peace. A light that revealed the deepest, most terrifying capabilities of the human mind. That light has faded, but its image is burned into our history. It remains there, a permanent warning. A silent, glowing reminder of the thin line we walk, the fragile peace we keep, and the awesome, terrifying, and unending question of what we will choose to do with the time that we have left. Under the watchful eye of a sun we now know how to imitate. The story is not over. It is being written, every day, in the choices we make. And the silence that follows is a silence filled with both hope and with dread.